All right. Hi, everyone. It's about that time. We are going to be starting our afternoon sessions with a first panel with VCs to understand a little bit more about the industry. And also, just a reminder, right, we still have some food, some snacks, some drinks. Please go ahead and grab as much as you can if you're still hungry, if you're still thirsty. Find a place to sit down, and we'll begin shortly. Also, on the second floor, we have workshops going on. Currently, Hyper Oracle is about to start. So if you're interested in any sort of workshops, getting your hands dirty, again, go up to the second floor. You can find the stairs right behind near the entrance. Okay, and so without further ado, I'll have Rayhan come up. She'll be emceeing and hosting for the panels this afternoon, and she'll be introducing the first panel. Thank you. And also, attention, attention. All right, thank you.
Hello, everyone. Welcome to zkDay. And this will be our first panel, VC panel. Where is the long-term value of ZK? So let's welcome Luke from Polychain Capital, Will from Galaxy, Louis from 7X Venture, Queenie from IOSG, Roy from Hashkey, and friends from Flow Traders. Stage is all yours.
Hello, hello. Thank you very much for that little introduction. Are we good? We're good. Can you hear me? Yeah? We're good? Okay, well, welcome. Good afternoon, everybody. For those who weren't closer.
We need to turn it off.
Yeah, we'll have a go now. Yeah, we're good? Sorry, the audibility of the room's interesting from this particular seat. For those who didn't make the morning introduction, my name is Luke Pearson. I'm a research cryptographer at Polychain Capital. I work on the research and investments team and have the absolute pleasure of moderating the panel with my lovely panelist guests from an eclectic variety of backgrounds. I'll let them introduce themselves in a second. I think, fortunately for us, not to have to tread on the toes of some of the other talks, we have ourselves a nice generic title. So we just want to chat for a little 50 minutes, chat with some questions in the audience, speak about some themes, talk mostly really close. Okay, there we are. Being, of course, the long-term value of zero knowledge, this very, very powerful tool which over the past years, 30 years, has took off exponentially. I think with a great interest into what it can do with distributed ledgers, what it can do to peer-to-peer networks, solving some of the existing problems in blockchains, and we'll speak about some scalability, some privacy, and try and keep things hopefully nice and broad for everybody to listen to. So I'll allow people to introduce themselves one at a time, and then we'll fire off with some fun discussion.
Well, thanks, Luke. Thanks, Luke. It's great to be here. My name is Roy, partner and head of US for Hashkey Capital. I'll give you guys a brief background. So we've been around since 2015. Legend has it, we were the very first institutional check into Ethereum. So you've seen that meme where Vitalik is in the karaoke. I think that was us. Not to flex, but going back to history is fun. We're really lucky to back some of the pioneers in ZK, and we continue to work together with the founders in our network. We've just onboarded. We just onboarded a group of advisors in cryptography from the Groth Lab, the Groth 16 Groth Lab, as well as Agilus Lab. So we're very excited to begin to export some of our internal proprietary research in this space, and I'm really lucky to be here today and chat with some of the brightest minds in the space.
Hello everyone, I'm Queenie. I'm with IOSG Ventures. So IOSG Ventures is an early stage research-driven Web3 native fund in the space since 2017. So we've been actively investing in zk space since early 2020 and got really good exposure in this sector. And I'm really excited to be here to see a lot of familiar faces and the smart people here. And I'm also very happy to see our portfolios today, like Neo Foundation and Scroll. I'm really proud of them. Yeah, thank you.
Hey, hello everyone. Hey, Luis again here. So I'm from CyberX Ventures. For those who not in the morning, I just make a brief introduction of CyberX. We are the research crypto fund in Asia. So we are extremely exciting to support some founders here. So with all our investment thesis, the innovation on zk have been our main thesis. And I'm happy to meet all the builders and all the other investors here. Thank you.
Hi, I'm Will. I work on venture investing for Galaxy Digital. We're a trading and investing firm based in New York. Been around for a couple of years. Hello.
Good. Okay, my name is Frans. I work at Flow Traders. We're a global market maker based in Amsterdam, but we have offices globally. We invest, but more importantly, we provide liquidity across exchanges.
Okay, awesome. And hopefully we won't continue with the high-pitched noises. As a first generic and almost pilot question to set the tone and speak about our lovely zk title. Where do you feel, sitting on what I think people in these chairs have a unique side of the fence, perhaps builders, perhaps researchers, perhaps investors within firms, early backers. Where do you feel this technology is moving on its path of natural maturity? Just kind of unpack that a little bit. The progression of zero knowledge and its requirement to solve some of the problems within blockchain it's arguably taken a small hit recently, whether in confidence. It could be as specific as technical as, well, we don't need loads of zero knowledge L2 scaling Ethereum platforms if no one's using this base layer. Or it can be, who wants to sit and code open source mixers if you're going to end up in a Dutch jail for months and months on end. And from that sentiment of where we are, how you feel this room, what do you think the short to medium term future holds?
That was a really big question. I think I would start by kind of putting things in perspective and define the stack that we're looking at. A lot of the innovation has happened more on the infrastructure level, so theoretical, best proving systems down to the circuits, then to compilers, to the hardware acceleration. But I have a lot of interest in seeing how this could unfold for the end user. So in my view, at least, what AI was to Web 2, zk is to Web 3. And the biggest difference is AI is a massively inherently centralizing force, whereas zk is very much a decentralizing force. So if you think about your everyday usage, and this goes back to long-term value, we go to Chase, we go to Bank of America for banking, we go to Uber for ride-hailing, and these brands are important because it comes with a sense of trust. But with zk, if you can verify the profile, the background, the reviews of a particular driver, for example, then you no longer need to just trust Uber as a brand. We can really power a truly decentralized and P2B economy. So I think in the short term, we still got a lot to figure out, and I'm really excited to go on this path with everyone in this room. But say 10, 20 years, which is how long AI has taken to bring us here and now with ChatGPT, we could be looking at a true decentralized economy built on zk.
From my perspective, I think we're still at a very early stage, in this, zk direction, because even though this technology has been there for several decades, but it's just recent several years that we use it in blockchain or to enhance certain features in blockchain. So even though I know there are a lot of projects, they're approaching their mainnet or official launch, but it's still very far away from a truly trustless system. As we can see, like some parts of the system, like the sequencer, like the prover, they're still like set in a centralized way, right? So and also the whole system hasn't been battle tested, so there might also be some security issues. So we're definitely, at very, very early stage. And as for the long-term value, I think I want to mention something here, like zero-knowledge proofs itself is not the purpose. So it's just a tool to address certain demands or problem that can create a market. So yeah, so we don't create problems for zk to solve, but we use zk to solve problems. So just take zk rollup as an example. I think it's the best example because it's aimed to solve the scaling problem of Ethereum, but the validity proof, this property of zero-knowledge proofs, can enable this computational integrity in a very trustless way. So that's the beauty of it. Yeah.
So I think I totally agree with Queenie about the zero knowledge currently still in early stage. You can see all the zk rollups, they are on testnet, not on mainnet yet. So we are seeing a lot of the zk bridge, zk cross-chain, zk oracles coming out this year. It's still in early stage. But we extremely feel exciting about zk technology because back to like the original spirit of the crypto space is trustless and permissionless. And we cannot use the consensus and tokenomics trying to make sure everyone doing the right thing. But with zk technology, we actually can actually help evolve the consensus with the technology to basically make sure the trustness about the whole blockchain. That's what we are really exciting. And also, what we can say that besides the zk rollup, we have the zk bridge, which is amazing. We have so many projects built on that, trying to solve the bridge problem, like a lot of like a hiking privacy issue with the blockchain. And back to Roy's question about DF, like so we recently, I think here are some builders build a fully on-chain gamings. So at 7x, we are fully bullish on fully on-chain gamings, as we think it basically unlocks a new kind of the version of the gaming totally on blockchain, and with the zk technology embraced with the fully on-chain gamings to make sure the privacy and they can have the private strategy, and also for the scaling issue and also fully on-chain gaming, we see the huge potential. So even though it's very early, so we are very bullish. We are very excited to see like how the zk technology will shape the whole industry, and also to help the more verticals in the blockchain space.
Yeah, I mean, at the application layer, on-chain gaming, some of the other things you mentioned, decentralized identity are all interesting. I think there's a broad approach, and I was down in Tel Aviv for the Starkware Summit a couple weeks ago, and Eli Ben-Sasson, who's the founder of Starkware, said something that was really, really thoughtful and rings really true, which is blockchains are ultimately compute-constrained environments, right? They're basically computers with a strong constraint on the types of computations you can run, the scale of computations you can run. You're never going to be able to run, obviously a machine learning algorithm or even some, more simple algorithm, a linear, large linear regressions, other things on an L1 blockchain. There's a natural fit between zero knowledge and L1s, given that they are compute-constrained environments, because you don't no longer need on an L1 to actually perform all the execution of compute. All you need to do is outsource the execution of compute to a layer 2 or some other utility which performs it and then provides a zero knowledge proof. So there's an inherent fit between blockchains and zero knowledge that I think has a sort of a trajectory that is just going one direction. Eventually, most of the block space on ETH will probably be taken up by some mix of optimistic rollups and then zero-knowledge rollups over a long enough time horizon. The thing that we're paying attention to ultimately is performance, right? You've got this kind of concept in economics called induced demand, right? As the price of something falls, you induce more use cases to sort of fulfill the supply. I think we'll see something similar in zero knowledge. Right now, the performance is just pretty limited. Over time, I mean, I've heard different opinions about when performance gets unlocked and when you get to relevant levels for different applications and technologies, but there is a kind of thought that there could be a Moore's law type scaling in zero knowledge performance and zero knowledge hardware. So we'll pay attention to that, and over time, that's what we're looking at. It is early because the performance of these systems is pretty limited today, but there's a natural fit and a trajectory between the two, is the view of Galaxy.
Not that much to add after all these smart things that have been said, but mostly from a trading perspective, what you said about performance and scalability, yeah, just from a trading perspective, that's just very interesting, where you can actually build a central limit order book that works and have performance that backs it up. So I can think those are very logical, interesting areas for us at least.
Yeah, I think some excellent answers, and definitely fair to say that the sentiment is far more positive than the way I laid out the question, even redacting any three-letter acronym, I don't know, people or organizations that have kind of destroyed everything. So I think that's fantastic. I think the focus on where we are on the technology curve is really, really important, not just for predicting and guessing. The kind of chicken-egg question, also the chicken-egg point that came up of you provide these scalability platforms or well-scaled platforms, and then the use cases sort of come, or how can you predict that? I think is very, very interesting. But because a lot of the research and deployment is done in a permissionless environment, it's done in teams building open source software, we have a very unique duty whilst we're on this curve. Hopefully we're still far from the exponent to build, I think, in a very particular way, to ensure that we don't have the same or make the same mistakes as some of our predecessors, people who were building DARPANET and then adding SSL sort of 25 years later and kind of destroying many of the aspects of financial cryptography and transactions over the internet. So I think being mindful, whether you're an investor, a builder, a researcher, of how and why we're moving along this curve, I think is really important. So some excellent answers. But speeding along, one thing, or I'd say the thing that's taken zero knowledge to its height and it's become its a great talking point recently is not its kind of initial advent of privacy. It's not the actual zk. To be pedantic, it's the S. It's the S of the snark. It's the succinctness. It's this ability to verify something done on a client side, perhaps really expensively, really quickly in a nice peer-to-peer environment. And as a result, privacy's fallen down a little bit. I think it's great for zero knowledge as a whole to be taken forward by scalability, but it's overtaken it, and we still exist, and there are companies here today, there are protocols and projects all over trying to solve certain privacy aspects of blockchains. But if you have tentative public blockchains, it's very difficult to have or to allow certain behaviors. Lots of behaviors are simply not feasible. They're just not possible. Certain gaming, certain selective voting, certain DAO infrastructure, certain payrolls. And it can be really, really hard to get people to care about these things. I've spent a fair portion of the past year talking to people at conferences, and the interest in privacy doesn't seem to really be there. What do you think is the greatest steps to allowing people to see the light? Or do you think it's just better to put placeholder infrastructure in the background that people don't care about, and it'll just allow them to run things for, on-chain, two-person game styles? What do you think is the best way to pierce privacy back into the argument? Will, take it away. It looked like it was on the tip of your tongue.
Yeah, there's a couple different applications on the privacy side that I think are relevant to us. I think I sit definitely in the camp that succinctness is the important property of zero knowledge proofs. Probably won't deviate from that view. I mean, the power of succinctness when it comes to re-execution of transactions, or lack of re-execution of transactions, is powerful. That said, there's definitely a place for the component of privacy. Things like, and we spend a lot of time on, and we have an investment in, which is zero knowledge proofs of identity, as well as zero knowledge proofs of compliance with certain regulatory regimes. I know that's kind of unsexy and a relatively unpopular portion of the industry, but being on the Galaxy side of things, fairly tangential to institutions that are outside of crypto, we know that the problem space is serious when it comes to operating on chain with unknown counterparties and other things like that. So compliance with regulatory regimes without sharing identity information, I know is going to sound unpopular. There's obviously, I think, applications in privacy to capital markets on chain. The reality is, if I sit here and say to you guys today, blockchains are a better rail to conduct financial services on, that's all well and good, and I do believe that. But fundamentally, large banks, large asset managers, they're not issuing bonds on a fully public system. They've said that to us. It's just not happening. So I think we may end up in a world where you get private permissioned layer 2s, you get public L2s, you kind of get them commingled alongside of each other. But privacy is really relevant in those applications. But succinctness really is my focus. I'm sure others have feelings about where privacy fits into the ecosystem using zero knowledge.
Yeah, I definitely think the DID area is definitely the zkDid is a very interesting one. So currently we have the different DID ecosystem through the whole different ecosystem. Like in Ethereum we have ENS, and Solana have Bonfida, SNS. But how can we transfer the different DID to do a combination of the one DID and also combine your Web2 ID to the Web3 ID? So the zk technology, the privacy is definitely the one to help you transfer the DID into do a one combination. Once you have the single type of DID, you can do credit scoring or other things in DeFi and other stuff. And also on gaming side or DeFi side, the automation is always super interesting. Because you as a institution or retail trader, you don't really want to share your strategy for trading, your strategy to play the on-chain gaming to others. Then the zk technology can help you to hide your strategy. You can still doing the automation to execute your strategy, but you won't release what kind of exactly of the strategy you are. That's kind of my view. How about you, Queenie?
Well, I think privacy is really complicated and a multidimensional question. So it's about the information we're talking about. What kind of information? Your assets, or your personal privacy information, and what the users, their different social background or culture background or etc. And also the cost for paying privacy, etc. So I believe there will be different use cases adopting privacy. So that's why we've already seen Tornado Cash got great traction, and also there are a lot of projects working on DID, etc. So I do believe privacy is a must in this blockchain world, but the users can choose whether to use it or not. Yeah, and I think some other interesting questions about privacy can be first, whether the general purpose layer 1 or layer 2, they should natively support privacy features or not. From my understanding, currently almost all the zk rollups except for Aztec, they are mainly solving a scaling problem. I think using zero knowledge proofs to solve one single problem is already complicated enough. So I don't think in the short term, they can simultaneously support the privacy feature natively, but they can work with others maybe to enable this a plug-in feature or in a modular way or something like that. Yeah. So, and also the second question might be related to the regulation side, how we ensure that people enjoy this a privacy feature but are not doing something evil. Yeah. In this case, I currently don't have any ideas at how to solve it, but probably zk can be also applied here. Yeah, I would love to hear more ideas if people, have some thoughts about it.
Yeah, I like to double click on the concept around succinctness of snarks and starks. That's like the sexiest part, and even sexier part is recursion. So not only can you reduce thousands of transactions into one proof, you can do proofs on a collection of proofs. So that type of scalability is mind-boggling, right? And I think we're at the cycle of the blockchain evolution where this is most critical right now. I've seen competing data where we started with, 15 million wallet addresses in 2017, and now we're at 300 million. So, that's another like 6x, and we're into the billions with the next bull cycle. We're not ready for billions of people to onboard a blockchain. So while as interesting privacy as a concept and important it is, I do think the most critical issue right now is scalability. And zk, we're seeing some hardware acceleration companies that are in the tape out phase. So we may see some chips coming out in the next couple of years. Obviously, there is a whole competition going on amongst all the zk EVMs at different types of compatibility. Or zk VMs, if we start marrying zk acceleration with modular blockchain, that's where things become really interesting, because EVMs inherently are not prone and compatible to parallel processing. But so that in itself will be unlocked with modular blockchain. So we're paying a lot of attention to layer 1, layer 2 acceleration, to middleware, to every step in the current ecosystem that can prepare us to onboard billions of users with the next bull cycle.
Yeah, good stuff. Again, not much to add. I think on the first part, that is interesting. If you get into the combination of scaling, privacy, and then trust and verifying, in my view, compliance, again, boring, but that is a place where this technology can play a huge role. I think post-financial crisis, there's been much more focus on compliance, but in a way, compliance is important, but it's also a business killer. And one of our biggest frictions is doing the onboardings, trusting people, and then being able to trade with people and doing business. So if it can make that less exciting part of our lives easier, then zk is already, in my view, very valuable technology to have.
Again, of course, excellent points from everyone. Wrapping up, moving on, should I say. But I want to pick on one particular aspect about the comparison between succinctness and privacy. And I feel that they are two sides of a very different coin. It's fantastic for users and the gratification people can get today by looking at L2 platforms and seeing things scale and seeing gas go down and seeing it become viable to have high transaction throughput and have fantastic roll-ups with immediate work, and presenting privacy from the same proving systems in parallel to the same user benefit, I think is an incorrect way to go about it. Privacy is far more binary. What it allows isn't this crescendo of better life already in blockchain. It's just we have public blockchains, or many of them public by default, and tons of behaviors that you have in the real world that you just cannot yet do, so long as every man and his dog can jump on a block explorer and maybe without de-anonymizing the actual address holder see all of this information as I think a very, very large problem. But given that we can't yet do both, Aztec are giving it a good go. For now, I think snarks and the scaling as a bit of a Trojan horse has been far more fantastic. So thinking about where we go when we have these well-scale platforms, you spend many, many, many hours with eyes and show things that are brought across your desk from projects and ideas all over the world, in and outside of the blockchain space, with great privacy and scaling properties. The aim is ultimately to have a point of sale style like Visa or MasterCard, and we have this full settlement layer wherever it's been doing, so we'll talk about it in the next question. But are there any particular newer niche cases in your sectors that you are seeing advent and come about at the intersection of zero knowledge and DLTs, P2P networks, or even without blockchains outside of a decentralized context?
Yeah, to get back into the trading, I think zk will allow you to have both privacy and scalability, in the sense that in trading, it's good to see what sort of, if you're on an exchange, it's good to see what market share there is and who does what to a certain degree. But too much visibility, which public blockchains give, allow people to front run and do other malicious things, which are then detrimental to, probably, the buyer and the seller on both sides. And that is again something which zero knowledge proofs can solve, and which some certain projects are already doing. And that is something we as a firm, you need to balance how the privacy is viewed and what the atmosphere is around that in these times. But it is an area where I think positive improvements will be made.
How do you see that actually playing out? Is that a dark pool? Is that a fully zk order book? How do you imagine it? Like, what does the actual infrastructure look like if that comes to fruition?
I guess you'll have both, depending on what demand there is. Basically, like you have in traditional finance. So either you can have a central limit order book in which you see all the buys and sell and all the orders, and there you have arguably more transparency, but you maybe don't want everybody to see what your account balance is and exactly what you're doing, because that gives away your advantage to other people who can take advantage of that. And you can set up, if there's a demand, you can set up a pool, call it a dark pool, but dark pools have a bad name. But it can be valuable if you have certain flow which people want to share, potentially in a positive way. But many books have been written about this, so I guess for many people who are not into trading, dark pools can be seen as a negative, but they're not always the case.
So I think for my side, it's all about I will talk about again about fully on-chain gaming, but I know probably many of people here will question why we need the gaming logic on-chain, why we need all those kind of the perspective on-chain. I think the fully on-chain gaming will be different from the Web2 game. They just create a new world, an autonomous world, and they just set several rules of this world. Then every developer can build their own the front end. They can build their own strategy, even their own game to compete with each other. So with that kind of the unlocking the new kind of the competitiveness and the gaming theory, to make the more people to compete with each other with some kind of the sovereign to build their own things, to feel more participate in the game. What we say the huge potential about the fully on-chain gaming. But with the current blockchain architecture is not possible. The first is a scalability issue. You can see all the fully on-chain gaming right now is not even 2D game. It's a pixel game. So it's not fun at all. The secondly is they can take more than the 10K users. It's impossible. So from a scalability perspective, it's definitely if we use zk to put all the computing off-chain and make sure that ZKP on-chain, that's kind of to solve the scalability issue. The second thing is because it's you can see from Dark Forest, it's a competitiveness between different players. You play your own strategy, and you don't want anyone else to know your strategy you play. So if we use the current blockchain, then all your strategy will be on blockchain. Everyone can see your strategy. And that's the reason why with the privacy of the zk technology, they actually can have the private strategy. It's what another kind of the zk use on fully on-chain gaming. So as a fund, so we see the fully on-chain gaming right now probably similar to zk technology back to 2017, 2018. It's still very early, but we see the huge potential of the fully on-chain gaming.
For me, I think there's still a great chance that utilizing zero-knowledge proofs can improve the current, some part of the blockchain infrastructure, such as Bridge and such as Oracle, because all these infrastructures still have some risk of centralization, and I believe zero-knowledge proofs can solve some problems here. As for more niche use cases, I think it's possible that we can use zero-knowledge proofs with some other technologies to create a better tool, such as, for example, maybe you can use zero-knowledge proofs with a random number generator. So we can make a fully decentralized on-chain random number generator, and then it can be used into on-chain gaming or some other scenarios. And there are also been some teams they're building zk AI or zk machine learning stuff, but I haven't dived deep into it yet, so I can't comment right now. Yeah.
I'll highlight one use case because we're talking about in blockchain, but I think zero knowledge is one of the probably top few innovations in cryptography since the invention of RSA. And it seems likely that there's going to be applications outside of blockchain. One of them that comes to mind is in the energy space. So the grid has millions of computers on it that are running grid control algorithms. They're usually PID controller kind of algorithms. There's some interesting applications as well of zero knowledge to potentially prove the outputs of the grid control algorithms, so that you get guarantees that you don't have essentially a vulnerability in the compute you're running. There's a group out in called the National Renewable Energy Laboratory, which has done some work implementing some of the grid control algorithms, which are written in C++, implementing them in CIRCOM, and then using zero-knowledge proofs to prove the outputs of those computations. So there's some interesting work being done outside of the blockchain space with respect to zero-knowledge, but it's without a doubt true that blockchain and the work that our space has done in the last 5 years has been a forceful driver of the technology. But I think we're all looking forward to, or at least I'm looking forward to, the potential applications of the technology outside of this space as well.
So I'll give two examples. One, we're also really excited, as Lewis has said, to bring gaming on chain. And right now, even at the current state of art, snarks, the gas prices are still way too high for all the players to process their transactions on chain. Even if the part of the execution is brought off chain, just to prove and then verify and have that gas price rebated is going to be a lot of pressure on either the user or the gaming companies. So that's one area we're excited about in terms of zk's scalability properties. And then another area that's very exploratory is the intercept of zk and ML. So I was chatting with a couple of researchers that were saying, for example, you can't really tell what photos are real anymore, but theoretically, you can have the origin, the base photo hashed out, and then run that entire ML training process, then prove that entire process. So even in photos that are enhanced, you can still trace it back to the original photo. And I think this is just really interesting at a time when AI has become so good that zk can almost become some sort of defense, so that as humans we still know what is human.
Yeah, I feel some brand new sectors and intersections with zero knowledge discussed there. I must say on that question, because it can be very difficult to think or attempt to put yourself in a paradigm where you're building on technology that doesn't yet exist. Making predictions, let's say, of where you would drive before cars were invented. But I think seeing it peer into ML, seeing it peer into the energy networks, and just go with the same level of innovate first, go fast and break things, and then move forward and add platforms on top of whatever hopefully well-scaled platforms we design. I want to do one final question before some audience questions, and just to wrap a little bit more, I think, controversial Twitter-esque going on of zkL2s versus alt zkL1s. So how do you feel that values accrues to different networks or different protocols which are taking embedding zero knowledge into the design? This plays very heavily into a flagship and I would say helpful point for this question of, do we have a world where we just have Ethereum that's well scaled and, for argument's sake, ultimately private, or do we have the coexisting and the harmony of all of these alternative L1s that have got zero knowledge in baked into their design, whether it be Mina for lightweight and recursion, whether it be for Alio for some upgradability? People are focusing very heavily now on the developer experience. Are we going to continue to expect people to just learn Solidity, keep learning DSL after DSL, keep making tooling for one of these languages, or is it better to go the kind of other extreme and maybe drop like a zkVM argument, move to a RISC-V instruction set? So rather than the 18,000 developers that code in Solidity in the world, you can take everybody writing in C++, Rust, something with static bindings. I'm sure eventually some innovator will do it with dynamic as well, a place where you're running ELFs. How do you see the long-term environment planning out between alt zkL1s and zkL2s? Feel free to jump, whoever really wants to take the question.
Yeah, probably I'll go first. I think so with true whole landscape of blockchain, currently we have like the Ethereum as L1, and we have different kinds of L2 focusing on different areas. Then we have L3 kind of concept, some focusing on scaling, some focusing on privacy. And besides Ethereum, we have the Celestia ecosystem, modular blockchain, doing like the execution layer, settlement layer, and DA layer. And I also talking some really super interesting research teams that are building the module, trying to do the ZK proof binding from L2 to L1 to help them do the settlement on L1 with a lower fee and also without like with a good scalability. So I think with currently the Ethereum like or Celestia or Cosmos, some kinds of like the blockchain space, and also a roll-up as service, we already can fulfill most of the application needs. That reason why, like, at this point, personally, just a personal opinion, not 7x opinion. So I'm not really sure about building a new L1, because building a new L1 is not about just like building a product technology. It's also how to use Bootstrap. Like the Ethereum got a very good base of developer base and asset base. And how can another L1 trying to copy that to start all over again? So I still feel like L2, L3, those kind of concepts is more like the small songs for me rather than building a new L1. But just a personal opinion.
I also agree with you. Actually, I'm a Ethereum maxi. So I really believe in the future of Ethereum, because in this space we've already seen the huge first mover advantage here, and we've already seen the network effect that Ethereum has already created. So we're seeing like a huge liquidity on Ethereum, and also like the best toolings, the developer toolings, and the best ecosystem support in terms of like the Explorer, wallets, etc. So I do feel like the new layer ones, no matter it's like ZK or not, it's really difficult for them to bootstrap the ecosystem. Like even though they're they might be very, good in tech. But I do believe maybe in the future there will be chain agnostic. So no matter like it's layer 1, layer 2, so everything will just get connected. Yeah.
Well, we only have a couple of minutes left. Do you want to do some audience questions? Yeah, I guess not as a question, but a nice food for thought is whether you believe that a modular thesis has been powered better by the use of zero-knowledge protocols, or would we be fine without these ZKPs and have state transition function enforcement on optimistic roll-ups, for example? But I think definitely something for a longer discussion on the back of what was just said. Are there any questions for any of our panelists or myself? Yeah, we have.
Hello. Awesome, yeah. So this entire day, we've been pretty much focusing kind of on the optimistic side of zk and all the positive sides of zk. So I want to kind of ask, like, what are some of the major roadblocks or negative things on zk that you think zk really needs to kind of cross that bridge, essentially, until it's actually really viable for sort of like widespread kind of use, whether that be legal, developmental, or kind of whatever?
Thank you for your question. I can go first. So I think security is one of the issues it's really, really paramount, but it has not been discussed enough and paid a lot of attention to. So we currently believe in the cryptographic hash functions that being used in this technology, right? But there's actually no proof that it's like absolutely secure. And also, I think there are limited security tools that we can use, and there are not enough like a professional in this field, like who knows security and also zero-knowledge proofs of this technology. So I do believe there are still a lot of challenges, and also like the prover system or all these algorithm is still evolving, and maybe the layer 2s and the other system, they need to upgrade their system, like how to ensure upgradability in a secure way. So I don't know. Maybe I need to ask the founders. Yeah, I think there's still a lot of challenges.
I think that was an excellent answer. And to add color more onto the security side, one of the largest problems comes with these fun and fantastical circuits. You black box this information as some generated witness inputs, and if there's a bug going on inside, it can be hard to know. Speak to the Veridice guys over in the corner building tooling for some of these things, but if you don't know what's going on inside of a circuit because it's done in zero knowledge, you get some issues with internal mechanics. Also, another one that's a big issue at the moment, writing these circuits. It's like Circom, Circe, writing things in Halo 2. Every changing front end, you have to be a bit of an expert cryptographer. Even teams making IRs, something like Anoma's making this vampire, which is fantastic because it compiles to like polynomial representations of several different proving systems, but it's hyper inefficient because they're already kind of inefficient, and you're making an IR which has to be generic enough to compile to different types of proving systems. It's just building these circuits and doing them all by hand as well. There's no optimizations done, with what I think would be really great use case of machine learning algorithms. If we're going to have very large opcodes for VMs like the EVM, and people are re-optimizing and rewriting the lowest level they can just to fit these circuits, that's not it's fine because Web3 still hasn't reached critical mass, but it's obviously not scalable because it basically requires human input. So I think circuit writing is a really big one. Security is a very large one. And feasibility is still there. Some of the proving systems are, should we say, fast under perfect conditions. Now we've gone from iterations of a lot of proving systems from like 2015, like Groth, Aurora, Hyrax, all these things, and kind of slowed down in 2019 because we were roughly done with the maths, got faster implementations in browser and WASM, and now we're at the hardware problem. So it's still not fast enough. I think it's great that we're closer to that frontier, but viability and trying to squeeze out different optimizations that, you know, now the meta level's a big difficulty, and another difficulty inside hardware, which we didn't even touch on, is designing custom ASICs, let's say, or even specialized GPU algorithms. It's nice for something that does, you know, lots of parallelized MSM for some proving system, but if you have a weird split between MSMs and NTTs, and you make these algorithms not for F1 not for like instances of FPGAs, but you make algorithms for like hardware that's going to be sold in shop, and then that protocol just upsticks and changes the proving system, and you're left with a circuit which you'll have maybe been a genius and able to make generic enough to, you know, permeate what's going to be many proving systems, but for now it's likely that you just end up with lots of expensive, redundant ASICs. So I think the hardware is an issue, the security is an issue, and the circuit writings are an issue. But everything else just amazing.
Yeah, I'll say really quickly, yes, security. I think that's been discussed enough, so I won't add any more. The other two kind of risk points or challenges that I'm seeing is one, custody gateways. So we're super excited about zkDay IDs, but unfortunately, like at this stage, like the initial proving of whatever like license or ID or credit score that's off chain still needs to go through a trusted custodian with like the person who like executes it. And I see a lot of kind of like throttling and gateway risks around that kind of setup. And we might be many, many years away, if ever, until that is solved, because that does require our kind of off-chain agencies to buy in to the use of this zk technology. Another risk that's like I'm still getting a fear around is a little bit of what Luke was saying in terms of like all these DSLs and all these different methodologies in implementing certain proving systems. From what I understand, like, you know, we could still yet to see new proving systems that would require a whole different stack just to implement it. Just because like how early we are in this technology cycle, and which is fine because I think experimentation is great, but the risk is like a lot of the researchers are starting to spend more of their energy in commercialization. So, you know, I'm becoming a little bit more aware of like whether we're trading short-term gains for long-term game changers.
I guess time will tell. We are over time, but thank you very much. Please give a large round of applause for the panelists who traveled here. Thank you very much for listening.
Nice job. Yay. Alrighty. Just making sure. Are we ready? Oh, hello. So now we're having our first ZK panel. It's called ZK Applications, Programmability and Privacy. Let's welcome Wei Dai, Shumo from Menta, Anthony from Alio, Join from Aztec, and Yi from Axiom. Stage is all yours.
Should I say here? And no, I think we'll just sit next to all the panelists. Oh yeah. All right. Welcome, everyone. So apparently this is the first zk panel. So hope you're prepared for technical or otherwise. All right. So first, let's start off with some intros. So we have E here from Axiom, Anthony from AVL, and John here from Aztec, and Shumo from Manta. So if starting from E, you could introduce yourself a little bit, and one quick question, if you would like to include in your answer, what is one really exciting development in zk that you have seen recently?
Hey, my name's Yi. I'm one of the co-founders of Axiom, and one thing I'm really interested in is new proof systems such as Nova and Supernova that allow for very cheap aggregation and recursion for different zk proofs.
Hey everyone, my name is Anthony DiPrinzio. I work on growth at Aleo. Aleo is building a layer 1 blockchain that enables developers to build private and programmable applications on the web. One thing I'm really interested in the zk space is applications of zk in the machine learning area. There's some really interesting work going on around like neural nets and a few other areas. More on the tech side, I'm really interested in hardware acceleration, as I think it's a really important problem that needs to be solved for anybody building with zk. So yeah.
Hey everyone, John Wu here from Aztec. I lead growth for Aztec Network. We are building a next generation encrypted blockchain which will allow you to read and write to private state. One of the things I'm really excited about and we're very focused on is DevX and dev tooling, making this incredibly powerful technology accessible to millions of developers and not just the hundreds that exist today.
Hey everyone, my name is Shumo. I'm one of the co-founder of Manta Network. Myself, I'm particularly interested in two things. First is that how can we leverage the modern cryptography, namely proof aggregation in zero-knowledge proofs, to lower the entry barrier for building privacy-preserving zk applications. And second, I'm very interested in how can we help developers. Again, the name of the game here is lower the entry barrier to build powerful libraries and APIs for normal programmers can program zk applications.
So very interesting. So starting from Shumo, you mentioned you want to make zk more accessible and programmable. Can you talk more about OpenZL efforts?
Yeah, absolutely, right? So basically, OpenZL is a public good project we are building, right? I think some of the OpenZL authors are here, right? Please find the Manta crew and talk to them. But in general, the little bit story is that we are building zk layer 1, and we have a lot of pain in dev tooling. And then we decided, hey, it's just like insufferable to using existing toolings. Then we want to build better toolings first ourselves. And then we decided, hey, this is a very useful, potentially useful things to the broader public and the entire industry. They want to open source it, and then we build a public good project. So I wouldn't get into the lengthy technical details, right? Basically, OpenZL is proof system agnostic intermediate representations and heavily leverage the type theory embedded in Rust type systems to allow you to build like safely write circuit. So for example, all our own circuit is writing, despite our proof system backend are using ArcWorks, all our circuits are written using OpenZL. And I think in the future, we want to develop more things on top of OpenZL so that normal kind of programmers can be benefit from OpenZL. Yeah.
Comprehensive answer, Shumo. So moving on to Aztec. So John, you mentioned that Aztec v3 is going to be a privacy-focused rollup. How does Aztec v3 compare to all ones that focus on privacy? How does it compare to other rollups like Scroll or Optimism?
Yeah, one of the keys is we are building privacy first. And so the unique thing about Aztec 3, which is the code name for our next generation blockchain, is the interaction between public and private execution. And so being able to read and write to public state, just like Ethereum, and being able to read and write to private state. And that allows application developers to have full programmability in their applications, meaning you can integrate privacy, you can turn the privacy dial from 0 and be fully public, like Ethereum, all the way to fully private. and have everything be stored and executed in a private environment. And our first step to that is Noir, our universal zk language, which, like Shumo's efforts, is all about being back-end agnostic. And so we're very focused on future-proofing Aztec for the developer set, meaning if you pick up Noir today and a much better proving system gets developed than Berettenberg, which is our Plonk-based proving system, you should be able to plug into it. And I think one of the exciting things about ZKs today is nobody can see the future. I mean, I can't even imagine a year ago seeing however many people are in this room today. And the speed at which we're developing new back-end proving technologies means that tools like Noir, which allow you to flexibly plug in and out of backends, is going to be really critical.
Excellent summary and emphasis on programmability for ZK and backend agnostic programming languages. So moving on to Aleo, so coming off of the answer from John, what is Aleo and how does Aleo stand as an L1 that uses ZK as a first class primitive?
Yeah, so like I mentioned before, Aleo is building our own layer 1 blockchain that's designed for anybody that wants to build a private and programmable application. So think programmability of Ethereum combined with the privacy of Zcash. Everything we've built has been built from the ground up, and it's specifically focused on leveraging the privacy-preserving properties that ZK has to offer. I like to tell people ZK is a tool, right? You can use it in many different contexts. There's people using it for scaling and layer 2 solutions. There's people using it for privacy. There's people using it for both, just like Aztec. So from our perspective, the reason that we decided to actually go with the layer 1 model and design a ZK VM, not a ZK EVM, just drop the E, is because there's certain limitations with the EVM in terms of more complex private applications that maybe somebody wants to build. And so for us, it was really important to try and take a lot of these core principles and put them into something that developers could start using right away. And just like Aztec, we also have a ZK DSL called Leo, and this plugs directly one-to-one with our ZK VM, allowing for developers to tap into some of these more complex applications. And one of the cool things about Aleo is that most execution is done off-chain. So you basically generate a zero-knowledge proof. That proof gets uploaded on-chain. We did actually recently add functionalities that you can have on-chain state or shared state and on-chain computation. And the reason for that is because we wanted to enable developers to have more optionality. So for example, if you wanted to build a private Uniswap, for example, you need to have some kind of shared state on-chain. And so basically you as an application developer building on Aleo can decide, what do I want to have public, right, which you can do by executing a transaction off-chain. What do you want to have as public state, right, which you can do on-chain directly. And so again, this is sort of why we decided to build everything from the ground up.
Great, thanks for the answer. I really appreciate the public transitions that you have added to Aleo. It seems that there's really applications that you couldn't build, if you really want to do everything in ZK and off-chain. So coming to E. So can you talk a little bit more about Axiom, its use cases, and in particular, what type of exciting applications you have seen, that people have tried to build on top of Axiom and the Halo 2 library that you have?
Yeah, so Axiom is building a ZK coprocessor for Ethereum. What that means is we allow smart contracts to trustlessly access and process over any form of historic on-chain data. So imagine any data you could fetch from an archive node. We allow developers to use that data in their smart contract applications. And our mission is to make developers' use of ZK easy to actually experience the benefits of ZK for scaling. As part of that, we recently open sourced all of our ZK circuit code on our GitHub repo, and we're running an open source program. Basically, we believe that ZK technology should be developed for the community, by the community, and you can check out the program at axiom.xyz/open-source. As far as applications, we think that Axiom is useful in any setting where there's currently trust in an oracle that is unnecessary. So we're seeing a lot of that in DeFi, in liquid staking, and in airdrops. So if you have an application like that, visit axiom.xyz to get in touch. We're looking for early launch partners.
Thanks for the description of Axiom. So coming to the topic of programmability and accessibility, you mentioned that with this library that you have, it makes it really easy to program applications. So I actually want to ask Shumo the same question. What do you think accessibility is going to enable us to have if everyone can program in zk?
Yeah, I mean, I do have some academic background in programming language research, right? I think if you think about why today zk programming difficult, I would say there are two kinds of difficulties. One is inherent difficulties, because no matter how good the tooling is, that thing itself is very hard. And the second is kind of accidental difficulties by lack of good toolings, IDEs, programming languages, right? So I think my view basically is that zk programming is hard. There is inherent difficulties because it's not, the zk programming is not just programming your daily application logic, right? You are constructing, most of the zk programming, you are constructing cryptographic protocols and ways from the cryptographic academic background, right? If you want your cryptographic protocol to be secure, you need to worry about soundless, right? You need to worry about completeness, and you need to worry about zero logic for privacy-preserving applications. So based on these observations, my view is that it's not enough to just have zk DSLs. We want APIs, libraries, SDKs. So basically, I think our view is that we want to build something like PyTorch for zk, so that programmers not only writing zk DSL, they can just have a very easy way to call the APIs to build whatever they want to build. That's basically my take, yeah.
I think we might have a debate on hand because, I think OpenZL and Axiom is building libraries, while Aztec and Alio is building DSLs. So anything to respond to that, John or Anthony?
Yeah, happy to talk to that. I mean, Noir is a DSL, but we like to sell it as universal, meaning that it's pluggable into any backend. And the most important thing to just back up about the problem with zk today is that the hype to reality ratio is off the charts, even by crypto standards. There's maybe 1,000 zk developers in the universe, 25,000 monthly active total blockchain devs. And I think we should all look at ourselves in the mirror and be like, we failed if we can't get to 1 million devs. And for us, that's the path to adoption, right? And so the reason why we built Noir is for developers to have an easy-to-use tool that's really secure. And so one of the main issues that Shumo is mentioning is that you have to have two brains to develop cryptographic applications. One, you have to have an application developer brain, and then two, you need to have a cryptography background. And what we're trying to do is we're trying to clear the way for developers to just focus on building powerful applications without having to think about things like cryptographic security. And so that is really the focus of Noir, is to make it much, much simpler to reason about zk without having to know anything about the underlying cryptography.
Yeah, so just to add on to that, I echo a lot of what John has said. And specifically with the Leo programming language, we've taken the same philosophy where essentially what we're trying to do is abstract away the complexities of building with zero knowledge, right? Prior to this, you'd have to write your own circuits. Again, you'd have to have a cryptography background. In Alio, the way it works is we have Leo, which is a zk DSL/compiler. That goes to an intermediate representation called Alio instructions, which is much more assembly-like, which you can still build with and have more controls. And then that directly goes to R1CS. So we're basically trying to do all the hard work for you so that you, as a web developer who's familiar with Rust or TypeScript or one of these other languages, can just come in, hit the ground running, and start building whatever kind of zk application that you can imagine. So yeah, I'll just add on and say that.
Great answers from DSL camp. So onto Yi, maybe you can have the final say in this.
Yeah, I think the debate between DSL and API or framework is a little overblown. I think the distinctions really blur. Like Shumo, our goal at Axiom, we think we've achieved something which is at the difficulty level of TensorFlow 1.0 for writing zk circuits. Definitely not at TensorFlow 2.0, so go to our GitHub and try it out. But we think that in the long run, there will be DSLs, but you'll have to drop into the API level and the raw constraint level to get max performance. The reason we're starting with the API and framework today is to make a lot of applications that we're targeting at Axiom practical we really need to squeeze out every drop of performance, and it's a make or break for those applications. As things get more optimized with hardware acceleration and frankly with better cloud parallelization, we'll be able to use a DSL for gluing together these hyper-optimized pieces, which we think will always require some type of raw constraints or API.
Sure,
Can I jump in there real quick? Yeah, so I think one of the biggest, like this also goes with the barriers, is the hardware acceleration piece. And like we've thought a lot about that at Alio as well. So like in our architecture, we actually have provers on the network who run applications that are deployed on Alio, and they do this by generating zero-knowledge proofs. And so we've set up an entire mechanism, which is proof of work based, that actually incentivizes these provers to create more efficient hardware. Because if you can't get efficient hardware across the board, then like trying to build out any of these applications is going to be really difficult. So I think there's a lot of different ways you can think about how to achieve some of these efficiencies that we all want to get, but just through different mediums.
Right. So to summarize, there's a place for DSLs for more accessibility. There's a place for library because it allows you to do more low-level optimizations. And through hardware acceleration, hopefully we won't get too much performance penalty from DSLs. So I'll actually wrap back to Yi's point on gluing together, as you said, using DSL, these different components. Maybe on the topic of interoperability, how do you see zk applications interop with other zk applications? And moreover, how do zk applications interoperate with non-zk applications, right, on other chains?
Yeah, this is something that we're hyper-focused on at Axiom. So we've built a library to read from the data structures underlying Ethereum. And those are extremely unfriendly to zk. Ethereum, as you guys know, uses the catch-at hash function, which is probably the single most expensive operation in zk. And so our goal is to handle all of that for developers with hyper-optimized pieces, and then we allow developers to code in something that's closer to a zk DSL to put your application logic in. I think when you think about interoperating between zk systems, there's a big question of security. So the whole premise is that any zk snark system can verify any other one, which can lead to this combinatorial explosion of X verified and Y. But the question is, who's going to audit all of these systems, and how can the user really understand what's even happening? So we think the security story is pretty challenging, and one that we need to do a better job of explaining to users.
Yeah, go ahead, John.
Yeah, at Aztec, we've been thinking really hard about the interface between Aztec and Ethereum and public and private state for a really long time, which is why we chose this architecture of parallel public and private execution environments. We had this product called Aztec Connect, which is live on mainnet now, which allows you to make synchronous calls down to Ethereum L1. And so you kind of have to have a trade-off when you're moving from the private space to the public space. You're giving up a little bit of confidentiality, but not anonymity, right? You go into the public contract, and you're showing everyone what's happening, but nobody knows who you are. And so we aim to build this seamless kind of like back and forth between public and private states and execution environments into our next blockchain as well.
Trumo?
Yeah, I think maybe it's good. I think that's a good opportunity to give kind of like a general audience a little bit background on the difficulties between public state and private state, right? So how do you think about zk, right? My one sentence conclusion about zk is that zk is a transition function from one private state to another private state, right? But in the blockchain, we don't only have private state. We have public state as well. And how does zk this private state transition function compose with public states? That's all this kind of a question, discussion, or debate about. I think I feel like there are multiple ways of solving that, right? Of course, kind of like the original Zaxi paper by Alio folks, they have a take on this, right? But there are alternative approaches, right? So I think at Mantra we have been brainstorming a lot of things, basically about the composition between private state transition functions and the composition between public state transition functions, aka public smart contract, and the private state transition functions. I think, for example, right, there is one particular cryptographic technique called re-randomized commitment, right? You actually could use that very elegantly of composing these private state transition functions, as long as your private state transition function is designed in a modular way. That's where we are kind of focused on, and we put a lot of effort of designing these APIs so that these APIs, where underlying it's a private state transition function, can be composable with each other. That's basically our approach.
Great. So maybe I'll let Anthony answer this too, because we're on the same topic, right? So it seems that Aztec and Manta have converged on there's private transitions and public transitions, and it seems that Aleo have done the same. So I'll give you another chance to elaborate on that.
Yeah, so I think we have like a very similar thought process there in general. I guess the only thing I would add is that the way we position ourselves in talking about this topic is being private by default, right? So that means when you write a program in Aleo, for example, everything is written in a private state, and then you basically decide, okay, what information in a program is going to be public and what information is going to be private. Also on the side of an end user, you can decide what information you want to selectively reveal. And this is actually like very important to consider when looking at like regulation. And maybe this is a topic we'll get into later, but we all know regulation's around the corner, and we don't know exactly what that's going to look like, but it's really important that when we're designing these systems, we have an architecture such that we can evolve with whatever regulation is going to come about. And basically what I'm trying to say here is that having this separation between public and private state is really important to actually achieve that end goal. If you don't have that and you're 100% fully private, you might run into some scary issues down the line.
That's a great answer. But let me wrap up this discussion that we just had. So we're on the topic of interoperability, and so we have three kind of privacy teams, and interoperability there is really the question: how do you compose private and public states? And because in some cases you have the public states, and it seems that all three projects have arrived in the same conclusion, which is that you want to support private transitions at the same time. You want to have public states and then joint operates. And ETH's answer was that for Ethereum you have these complicated hash functions, and interoperability there in terms of proving state is to make this hash function more efficient. So now coming back to we just want to make sure we recap. There's quite a bit to unpack there. So now let's talk about regulation, and maybe let me set the stage a little bit. And when we talk about privacy, and that's where regulation comes from, right? And let me tie this into the previous question that you have answered, which is programmability. How do you think programmability will help us get a more regulatory compliant privacy infrastructure?
I think that's a great question, right? So I think first, I think regulation is a very muddy water, right? So I think we have talked to a lot of even regulators or privacy expert on this topic. I think the first thing is that what we wish is that we have a clarity in regulation, right? So for example, I think the biggest problem here is that how do you turn in English to a code? So let's say in an ideal world, right? zk toolings is 1,000x better than what we have today. And then you still have this problem of turning this legal documentation to code. And trust me, this is a non-trivial process. I think this requires kind of a co-evolution of the regulation itself and privacy project. But I think 100% programmability in privacy is much better than non-programmability, right? So basically, from ourselves, right, we're not taking extremes, right? We're not 100% cyberpunk mentality, but we're not also we want to root the decentralization. We want to root this movement, right? I think I feel like we need a clarification of which kind of programs we need to program to make the regulation compliance. I think one of the blog article every people should read is Vitalik's recent sales address article, right? I mean, to me, there are two extremes of the programmability. One is the global viewing keys for the government. I think this is bad, right? This is lose the entire purpose of this blockchain and decentralization. And the other is 100% non-compliance to regulation, kind of a Monero approach, right? I think I wish we can find something in between, right? And the industry can work with the government to make the privacy actually happens. Yeah, that's my point of view. Yeah.
Yeah, I think I definitely agree with that assessment. Privacy is a spectrum. Anything to add to that, from Aztec and Aleo?
Yeah, I think that's a great point. Programmability facilitates the dialogue, right? If you have a totally inflexible base layer that's either fully public or fully private, you don't really get to tune what's necessary. And we actually think the responsibility of talking to compliance, organizations and regulators, it should fall on applications. An application should get to choose the level of revelation they demand from their user base. And I think we should just focus on the word compliance for a second. Like, the word contains this other word, comply. Somebody's going to tell you to do something. If your blockchain is not flexible enough to allow for completely new paradigms for working with governments, then I think we're always going to be in this adversarial framework. And I don't think that's where any of us want to be, right? We don't want to fight a fight without actually having a dialogue about what some of these basic human rights mean for individuals.
Yeah, I mean, I basically agree with everything that's been said here. Maybe looking at it from like a more philosophical approach. I think the problem is when people talk about privacy, they're always in like defense. Like, we're being very defensive, and right, that always has like a negative connotation, like you're hiding in the shadows or you're doing some malicious activity, which is not the case, right? Like, we should be talking about this as like an enabling technology. Like, how do zero-knowledge proofs, by allowing you to have privacy in your application, actually yield us these new kinds of interesting business models, like these new interesting ways that people can interact on the web while maintaining their own data, all these sorts of things in a positive light. And I think if we push in that direction, coupled with what else was discussed here, I think the future, or the sky is the limit.
Yeah.
I think, to echo some of the points made earlier, the flow of regulation can go both ways. So in one sense, I think zk can actually do a lot for regulation, even with privacy turned off. So if you see a lot of examples of fraud, that's a case where regulation existed, but the bad actors simply disobeyed the law. Whereas if you imagine a system where actors have to affirmatively prove that they are allowed to do whatever action that they're taking, then that's an affirmative way to prevent fraud. So I think there's a lot of a dialogue to be had with the regulators that maybe some of the technologies we're building here can help regulation be better, even avoiding privacy, which I know they're kind of scared of.
Yeah, so I realized, we might have a stage of experts here, and can you give us more concrete example? Let's like zoom in on this detail, right? And what would be a concrete example? Let's say, I'm an Ethereum user. How does zk help me become more compliant?
Yeah, I think maybe this is not related to Ethereum, but one example is, what's the least trusted entity on Earth? I would say Facebook is a really good candidate. And suppose Facebook wants to show that they are not using your microphone data. So how can they do that? One way is that they can have the government regulate them and say, hey, we inspected Facebook, and they're not using your mic data. Well, of course, most people will just not believe that. I think the highest level of proof that they could give is some sort of zero-knowledge proof that they trained their model correctly, they're feeding you this recommendation, and it doesn't require your mic to do this. Now, this will require maybe a 10,000x improvement in zk, but that class of application, I think, is a case where cryptography offers a higher level of proof than any type of auditing or government regulation.
Got it. So, Shumo, I think there's some work that you have been doing along the same lines.
Yeah, I think same examples along ETH are probably more practical, right? So, for example, within the crypto space, like centralized exchange is probably one of the most least trusted entities, and now we can see a lot of centralized exchanges adding proof of reserve, right? I think having proof of reserve may not be enough for people who fully trust centralized exchange. I think that's definitely a good step towards this kind of examples, adding using zk, adding more trust.
Yeah, so perhaps for those of us in the audience that's not familiar, can you elaborate on what does proof of reserve mean?
So I think the centralized exchange hold the big custodian for people's coins, right? So then there is actually a counterparty risk, which is, for example, they may use your coins to do something else, right? Proof of reserve is basically this cryptographic protocol. Some are using zk, some are not using zk, but I think using zk's proof of reserve protocols are more popular these days, basically to allow the exchange to prove that the coins, the assets they hold for custodian for you is indeed there. It didn't leverage your coins to do something very suspicious, like FTX, right? That's a rough idea of proof of reserve. Yeah.
Got it. So, let me address this question to Aztec and Alio. Do you think your platforms, Aztec v3 and Alio, could help, exchanges build better, or just build proof of reserve products or disclosure mechanisms in general?
Yeah, absolutely. I mean, but I think it goes far beyond simple proof of reserves. I mean, people don't like to hear this, but you can have a notion of flexible compliance where an application says you have to hold a compliance token in order to enter the shielded pool. Now, outside of that pool, your privacy is preserved on the base layer, but in order to enter this one specific environment, you might need to enter a process that an application requires you. So, a KYC procedure, for instance. That's really flexible and pushes the level of compliance to each application dependent on their jurisdiction. The other thing we don't talk about is compliance is not monolithic, it's not universal. There are many, many jurisdictions around the world, and we need to have a system that's fully flexible enough for every protocol and every jurisdiction to kind of comply by their local rules. I'll just add one final thing, which is, I think one of the questions that we have is, how big should the black box be? You can have the whole system be one giant black box. I think we have ample evidence that sovereigns don't like that. But with programmability, you can make the black box as small as a single on-chain action. You can say, I'm just going to do a DAO vote, and I don't want anyone to know who I am or where the vote went. And I think sovereigns they would find that really easy to swallow. But you string enough of those small actions together, and you functionally have a bunch of user privacy.
Yeah, I guess just to add on to that, looking at a specific product that could implement some of these ideas is like a zkKYC solution, right? That maybe some of these entities could use as well. And this is something we're exploring at Alio. And like John was saying, the sky's the limit, or basically the expressivity you want to have in your application, where you want to apply privacy, like we've been saying all along, can be anywhere you want to have it. So at the end of the day, I think, that helps in general.
Yeah, so thanks for the great run of answers. So to summarize, regulation or information flow, privacy, it's a spectrum, right? So we have information that we want to keep hidden, information that we want to disclose, and programmability with zk allows us to really control what information is disclosed and in a verifiable manner. So I think let me kind of jump topics a little bit, if time permits. Since we're at a blockchain conference, let's talk about decentralization, right? And with all of the zk systems, with this, R2s, you might have very centralized provers, very centralized sequencers. How do we, as builders in zk, work more towards decentralization, in terms of proving or just protocol design in general? Anthony?
So I guess this is more of a philosophical question, if you think about it, right? It's I think the way we think about it at Alio is part of the reason these blockchain architectures exist is to enable a permissionless and censorship-resistant architecture, right? And for that, you need to have decentralization. And so, again, this is why if you look at Alio's architecture, proving architecture, we'll be decentralized right when we launch mainnet. And again, we are doing everything we can to try to incentivize people to enter this proof marketplace, essentially, and run provers to get it to be as decentralized as possible. So again, that's sort of the main philosophy for us. But if you don't care about decentralization, then maybe it doesn't matter as much, right? It just depends on what application set you're looking at and kind of what your priorities are.
Yeah, so decentralizing provers. I think Aztec might be working along the same lines. Do you want to comment on that, John?
Yeah, I mean, just on a higher level, ZKs are inherently somewhat more centralizing, right? That's the succinctness property of ZK is you roughly have this constant time verification, and you can jam in an arbitrarily large amount of compute into a big machine. Well, if you have a really big machine, just almost by definition, fewer people are going to be able to run it. And I think we just need to all come together almost through social consensus and be how much of this centralization trade-off are we willing to take for these immense, immense benefits in privacy and scalability that we get as a result? And I would definitely echo Anthony's point here that we obviously want these systems to be fully censorship resistant and have liveness guarantees. And I think it's a matter of figuring out where that line is drawn.
One other thing I would just add on to this. I mean, I don't know if people are familiar with zPrize, but this was like an initiative that Alio and a bunch of other projects in the space put together to essentially put out bounties so that people could create better hardware optimizations for generating zero-knowledge proofs. And the cool thing was, I think we saw between like a 2x to an 11x improvement across all the different categories, and everything's been open source. So it doesn't matter what project you're working on in the space, how you're using zk, like anybody can leverage these optimizations. So at the end of the day, that's our ultimate goal, and I think it generally benefits everybody in the ecosystem.
Definitely, I think the zPrize efforts really accelerated adoption and optimization of the zero knowledge algorithms. So maybe what do you think is the trade-off space between giant zk provers and client-side proofs? And yeah, go ahead.
Yeah, something we're thinking about at Axiom is the impact of the computational load of the statement you're proving on the level of decentralization that you're going to be able to achieve. So I think for something like a state transition on a rollup or an L1, that has to be computationally simple enough that you can really have a lot of redundancy and decentralization in the proof generation. If you're thinking about a much more complex statement, let's say neural network inference, well, we don't think that there's always going to be thousands of provers on demand to do inference on your neural network. Maybe that's going to require a sophisticated cloud setup to parallelize and achieve acceptable latencies. So there we think the problem is much closer to one that's experienced in MEV with sequencing and block building, where there will be some inherent returns to scale. And we think that the place for the market to hit is something where things are very transparent and open, and new players can join. But maybe the total level of decentralization won't be at the level of validators for a base layer blockchain.
Anything to add to that, Shuma?
Yeah, I think I kind of just conquer East Point. Just want to add my own take. I feel like, so the point of DK is leveraging this asymmetry, right? Because you can have a very, very beefy prover and hardware acceleration to prove a fact, and you verify that fact on chain. So you don't have to throw the job to consensus, let like 10K like validators to do the redundant computation again. But here, I think decentralization in terms of zk or like L2 or L3, I think we need to give it different meanings, right? To me, the decentralization here means optionality, which means that, hey, like, for example, all the L2s or L3s, like off-chain labs, like OP labs, they could run their own sequencer, but they should be permissionless and be open and to create this free market for the sequencers to join, right? I think that's, I would like to see more kind of like optionality in the space to, that's kind of my definition of decentralization, yeah.
Got it. So thanks for the great answers. So on the topic of decentralization, we talked about the spectrum of client-side proofs to big rollout proofs, and how there's this big spectrum in between, and how we integrate optionality, and how we should build towards decentralization, but at the same time realize that there's sometimes efficiency to be gained by having one zk prover. So let me wrap up a bit and open up to the audience here. So today we discussed about programmability of zk and what programmability of zk brings to the table in terms of accessibility for devs, programmable release information in terms of compliance, and we talk about decentralization. So I guess any last remarks before we open up to the audience? No? Okay, let's do it. How does this work? Anybody have a question? Raise your hand. Yeah. Do I have a mic going there?
Thanks all for speaking. It's very interesting. Curious about what your thoughts on this transition to post-quantum proving systems. Will we be able to reuse a lot of the infrastructure that's being built? How do we take that into account today? Kind of, how do we best prepare to eventually move to post-quantum? Or maybe we don't need to. I would also like to hear your thoughts there.
Anyone want to go first?
Yeah, I would say this ties back to the earlier discussion about building more modular proof systems. Initial zk applications were very monolithic on the cryptographic backend, But as things have progressed, there are different pieces that can be swapped in and out. And certain of those pieces are post-quantum and certain are not. I think, when you go post-quantum, you take a performance hit. And so in certain cases, we may not want to until there's a real threat. For Axiom, the choice is less severe because we don't do hidden information or privacy. So something getting broken in 100 years is not a big deal for us. But I'll let the other three panelists weigh in on the implications for privacy.
Yeah, I guess just to add on to that, like the current systems that people are using today, eventually they're going to be broken at some point. So I think that's a really good aspect that was just mentioned, which is basically like, I think just trying to design a lot of these like primitives the best way that we can now, and then basically, yeah, try to use them in future contexts, and then just, I guess, deal with like all of the downsides that come in the future is really the only way to go. But I think if we don't try to make any actions right now, then like you're just never going to make progress and you're going to stagnate. So it's definitely like a hard problem to solve for, but definitely something I think a lot of us are trying to think about when designing these systems.
Yeah, I mean, I think there is a painful way to migrate people into a new system through hard forking or I can't say that we're really looking ahead to a post-quantum world because it breaks a lot of, it breaks SHA, it breaks everything. So yeah, I think that world is, we're hoping pretty far off.
I just want to add a little bit. I'm not sure, maybe I'm kind of old enough to remember. There used to be an instance called the Millennium bug, right? After 2000, every computer will stop working. I think the key here is the social layer, right? I think it's great so many people, and also thanks you for asking the questions, right? So many people keep us aware of this question because we don't know how many years the quantum computer being there, but eventually it will be there. I think that's a majority of people believe. So we need to push the social layer to keep check and balance on this so that eventually it happens. We have plan B, we have a way of moving this secret state out to post-quantum secret state. I believe we can do that because I do think we have enough post-quantum awareness around the social cycle, yeah.
Yeah, I think, great round of answers, and I agree with everyone. Basically, it is, maybe not of immediate threat in terms of in the next couple of years, but definitely on a timeline of maybe 10 to 20, and it's definitely something we should be prepared for. And I would say, on the cryptography side, we do have like post-quantum primitives for most things that we can construct in cryptography. It is just that, in terms of efficiency, there's usually like additional factor. And I mean, we don't have to be too concerned, but at the same time, it should be something that's on the radar.
Yeah, basically what you just said is what when I first got into cryptography, I took Dan Benet's like intro to cryptography course online through Stanford, and I think that was like the key takeaway that I got from it at the end of the course, basically. So, yeah, just thought I knew.
Great. Any other questions?
Hi, thank you very much for the talk. I have two questions. One is something that Yi-Sun alluded to as well regarding the usage of ZKP around block production and sequencing, which is something that I'm also looking at very closely as part of my MEV research. So wanted to hear a bit more about that aspect. So that's one. Another question that I had was also a recent discussions that the Polygon teams had around the upgradability of the proof system when it's embedded in the, let's say, Aztec, Aleo, or Manta network, and that upgrading the proof system itself could be quite difficult. Some people may even call it impossible. So we'd love to also hear a bit more about like how do you guys think about, or if you have any plan around like potentially 5 years later down the road when you have a better proof system, that how are you gonna eventually update the proof system, for example?
Yeah, I think that was a question that addresses one of you.
Yeah, I can maybe talk about the proof system upgrade. I think it's very similar to semiconductor companies considering upgrading nodes. It's going to happen. You have to plan for it. I think it's about maintaining modularity in your circuit design and development. Most of these new proof systems do keep some sort of compatibility with the arithmetization of the circuits. And we actually rewrote 100% of our circuits from R1CS to our current Halo 2 stack last year. It took about 1 month, which is not so bad as these things go. It's going to take longer if we do it now, but we're just keep on our toes about that. Real quick about the transaction sequencing in MEV. I think it's very tough to do that synchronously in the sequencing flow, but I think doing post hoc and analytics on transactions for payment is something we're very interested in.
Yeah, on the upgradability side, I know this is a topic that people always talk about, right? Because when you upgrade, you're going to have some trusted third party to do that, or have some sort of process put in place to actually make that upgrade, which leaves yourself vulnerable to like hacks or various other like flaws. I mean, you can look at various different hacks throughout the crypto ecosystem, whether that's Nomad or other projects. We've kind of seen this happen already. I don't know if I have the best answer on how to specifically address upgrading while trying to avoid those flaws. I guess one approach would just to make sure that you have like really solid auditing teams kind of like looking at these upgrades and just having checks and balances across a number of different eyes to ensure that you don't run into any of those issues. But definitely like a challenging question.
I don't have a huge amount to add to that, except Noir compiles down to this intermediate representation, which hopefully gives us more flexibility in the future. But yes, some of these same transition problems remain.
Yeah, I just want to get down a little bit details of the upgradability, right? So I just want to remind ourselves, right? So people have done that successfully. For example, the OG privacy coin Zcash have successfully done a bunch of protocol updates, right? It's definitely doable. I think the devil's kind of in the details. So when we're talking about upgradability, there are two things. The first thing is the cryptographic protocol itself, the primitives, the hash function choices, the signature schemes, right? So you do need a little bit of foresight of choosing these things, because these things are harder to upgrade. And the second thing is circuit itself, right? It's totally possible to upgrade the proof systems as long as it's much easier. Let's say you keep the cryptographic primitive the same, but just upgrade the circuit, right? This does requires a little bit like foresight in terms of protocol design side. You want to using some hash functions like signature schemes, for example, post-quantum, or at least easy to migrate post-quantum, etc. And then you can upgrade the circuit. I do think, especially in our case, right? So actually not too many people aware of that, right? Because we're both building on Polkadot. And Polkadot has a trustless way of runtime upgrade. Like you don't need a hard fork. You just need to do our governance protocol. It will have a seamless protocol upgrade for all the Polkadot parachains, right? So we have done that successfully many times. And we believe we can do that if time comes. Yeah.
Yeah, so maybe quickly to add to that, there's like the algorithms, right, that's specified, and there's the states. I think it might be harder to upgrade the states. Like say if your state trees in, Ketchak, hashes, it might be hard to like change the hash there. And so, but yeah, so like I wouldn't like if the state tree stays the same, I would believe you could swap out the proofs into another. Yeah, so thanks for the round of answers. Let's take one more question from the audience. Matt.
All right. Okay, so you guys all have different approaches to ZK DDSLs or APIs for developers to use. But as you guys are aware, programming with ZK is a different model than on-chain execution right now, where you submit a transaction to a mempool and then wait for it to execute. So in your minds, given the different approaches you are each taking, what will ZK developers learn? Will they be learning circuits? How will they translate this existing programming mental model to the new one where it's not on-chain execution?
Great question, by the way.
Yeah, I can take first. So I have encountered numerous occasions. Basically, people come to me like, Shumo, I want to learn ZKP, right? My knee-jerk reaction is that go to Dan Bonnet's Intro to Crypto class, right? Because I find a lot of cases.
Great class, great class.
I mean, I found a lot of cases. The heart is not like master a programming language, right? Circom is easy to use, nor is very easy to use. It's about the mindset of building cryptographic protocols, and that you have to learn the cryptographic mental models. I think regardless of the ZKP, please learn some like a intro of cryptography. It's a science, right? It has its own mental model. It has its own kind of languages. It's good to master them, right? As for specific choices, I think for me, I think I would like to see different approaches, right? Like we're taking the API approach, and Aztec is taking a DSL approach. I think it's healthy for different approaches in the market, and people can learn from each other and getting the strengths of each other, and eventually we have a much better and better like ZK toolings. That's my take. Yeah.
Yeah, I would agree with that. I mean, one of our hopes is, of course, that you don't need to know, finite field arithmetic to be able to write ZK programs soon. But I think the trade-offs are just going to be a little bit orthogonal to how developers think today, right? One of the trade-offs today is just like gas intensity. In the future, we're not going to have to think about gas, but you're going to have to think about prover time, for instance. And so that's just a completely different set of trade-offs to Shumo's point. You're going to have to reprogram your brain to be like, okay, I get arbitrary amount of compute, but then that really affects, like, in our case, client-side proving time. Okay, we're going to have to retrain people on how to think with a completely new mental model when everyone's really been trained on gas. So I think, yeah, that's the biggest leap. And whether the path is through Dan Bonnet's class or really just thinking really hard about how this architecture functions differently, I have faith we're going to get there.
So I think we're almost at time, but 30 seconds questions.
Okay, yeah, 30 seconds. Yeah, for us, I think like one of the biggest challenges we've seen is like people coming in with this like mental model for like account-based systems, because a lot of people are coming from Ethereum. Whereas like on Aleo, we're primarily like, it's a hybrid, well, can't get too deep into it, but it's like a hybrid pro GTXO account. So I think it's just being able to, basically get more education around those kinds of frameworks and help people understand like this is why you need to be thinking in XYZ ways to, build your privacy application.
I think on our side, we think of the DSL versus API framework as two ways of getting to the same goal of writing circuits more efficiently. I think to touch on your other point, the mental model of developers calling into ZK proofs from smart contracts, that is very different. And it's much closer to making a call into an Oracle like Chainlink than operating synchronously in an on-chain smart contract setting. So it's a fundamentally more async, but more powerful setup.
Yeah, I also have a 15-second answer to that, which is actually fundamentally like the only difference I think technically is witness generation. You could have unconstrained computation that happens outside the circuit, which is then constrain the circuits. Everything else, I think, you can have abstractions over any type of computation, right, and compose them. But that like separate witness generation that's non-deterministic could be abstracted away. Anyways. So I think that was a very comprehensive panel, and thanks for the great questions from the audience. Let's thank our panelists.
Thanks for hosting.
Thanks, Wei.
Thanks for having us.
Yeah, thank you very much.
Thanks for every speaker on panel 2, on panel 1. And now we're having ZK panel 2, accelerating ZK adoption. Let's welcome Michael from Cointelegraph, Michael from Neo Foundation, Carden from HyperOracle, Leo from Cysic, and Brian from RISC-0.
Hello, everybody. Welcome to the second panel on accelerating ZK adoption. My name is Michael Tabone. I am the Deputy Director of Research at Cointelegraph, and I'd like to give everybody an opportunity to introduce themselves briefly, talk about your project. Go ahead.
How it works. Okay, well, since they made me to chill us a little bit anyway, so let's just do it. Okay, well, basically, what Neo Foundation is about, it's about, like, first of all, circuit compiler and the proof market. Some kind of infrastructure for ZK projects, that's what it is. Well, yeah, regarding the circuit compiler, it's an LLVM-based compiler. We're capable of compiling like CPP, Rust, Python, whatever LLVM supports into circuits, straight into circuits, like no VMs, no bytecode, nothing, just straight into circuits. And proof market like allows the market dynamics to reduce costs and timings of proof generation, like inducing a competition between proof generators, providing applications with like the best cost, like the best proofs, and at the same time providing provers with the access to the whole market of applications which need proofs. So that's what it is.
Okay, thank you.
Hello, hi, my name is Neil Fan. I'm a co-founder of SciSig. So at SciSig, we do have acceleration for the knowledge proofs. And we're right now in the FPGA phase, like our performance for the MSM is like 60 to 70 times faster than the Z-Price winner. And our ultimate goal is to build the ASIC for the ZKP. And with the with the ASIC, then we can build a proving network, and we can provide the proving as a service to our customers. Like, so that's our vision. Yeah.
Hi everyone, I'm Carton. I'm founder of HyperOracle. We are building a programmable zk Oracle. So traditionally, the Oracle and this middleware infrastructure, they're based on the staking and slashing mechanism. And right now we are replacing it with the zero knowledge proof, so that we can have completely decentralized and safe middleware for the blockchain. And so in the coming summer, we release our testnet, which will provide two meta applications, the zk indexing and zk automation. So basically, zk indexing allows user to any client, off-chain client, to take and verify the blockchain data from unknown third party with zero knowledge proof. And the zk automation will allow the DApp to do the verification of the off-chain computation and on-chain data in the current block, which is possible to use to do that without zero knowledge proof. Thank you.
I'm Brian Redford, the CEO at RiskZero. And at RiskZero, we build technology to allow regular programs to be executed in a ZK context. So that's the RiskZero ZK VM. And we are now building a new network called the Bonsai Network, which allows anybody to effectively run arbitrary code as like an accelerator alongside any chain. So you can outsource all of the complex logic of your game or order book or complex DApp to this sort of ZK co-processing network. Yeah.
Awesome. Thanks, guys, for introducing yourselves. So I have a quick fire question for everybody here. First off, Mikhail, you're first. Ready? Why should anyone care about ZK technology? Before we talk about adopting it and accelerating the adoption, why should we care about it?
Okay, well, basically the primary reason is, well, let's say it this way. You can either do a safe storage, you can either do a safe computation, okay? It's like, for the safe storage, we have all of those like protocols like ETH, whatever, all of those. And for secure computations, well, there is basically computation redundancy usually being done. But what if you need to use heavy secure computation within the secure data storage? So this is why we should care, basically, because this, all of that proof systems are often being misused as well. First of all, like the way of compressing large computations into, for example, ETH. Well, for example, that's what we do, but that's the first reason to care. Compression, efficient compression, that's the thing. And also there's a blinding option, which, well, enables some new use cases. Well, there was already like folks talking about like privacy and all of this stuff, so that's what it is. There's also, let's say it this way, there's also a third use case of that. Let's come to that a little bit later. We have a special question for that.
Yeah, absolutely. Thank you for that. Leo?
Yeah, I would second Mikhail's opinions. Like, there are basically like two nice features from this zero knowledge proofs. One is succinctness, and second is zero knowledgeness. For the succinctness, like we can rely on to build several like scaling projects such as Score here. And for the privacy part, the zero knowledge part, so the knowledge is basically to computation is what encryption to the messages. It can provide some privacy guarantee for different kinds of computations, and we can rely on this like privacy guarantee to have some private transactions on blockchain. So that's like what we care, like why we care in that part.
Absolutely. Thank you, Carton.
Yeah. So personally, I feel like zero knowledge proof. This technology is like as important as ECDSA, Merkle tree, and SHA-256. All kind of this technology we used to use to make a blockchain. And the reason why like zero knowledge proof like we just is about to be there to use it in blockchain is because the performance issue was not solved before. And it's not that many sophisticated library, but right now we have both. And so personally, I start my crypto journey from high school. I was amazed by like you can assemble the Merkle tree, SHA-256, ECDSA to make a blockchain called Bitcoin. And but there's two problems always trouble me. Like the first one is basically like how people in 30 years in the future verify the data we have today. Like basically it's impossible because it's like the block will be super long. And so I studied astronomy back to the college. And when I studied astronomy, I figured out a new solution by myself. I call it a black hole state. Basically this black hole block will summarize all the previous blockchain data and become a new genesis block. So we can control the length of the blockchain to like 10,000 block high forever. And later on, I know the zero knowledge proof in college, and then I think I don't really need this black hole state anymore. So you can basically just do the recursive proof for every block, and you can easily verify it in any time, even in 100 years from now. And the second problem trouble me is like, so basically here, the zero knowledge proof succinctness solve this problem. And then another problem trouble me is basically is like, why the heck we are still using like centralized RPC provider for a decentralized blockchain? That doesn't really make sense for me. So like, I start to think about how to let anybody to receive a blockchain data from someone else, even though they don't know them. They don't need to trust them. It's supposed to be like that, right? We don't need to be like, have a centralized server, be the media for us to touch the decentralized blockchain. And then I begin to talk about some like senior blockchain developers to see if it is possible with zero knowledge proof. And people was like, you are crazy back then, like a few months ago. And then later I find my co-founder Norman talk about it, and then we found it's possible actually. So with the zero knowledge proof, you can actually resolve a lot of the problem we used to have in blockchain. So that's super important.
Yeah, I think that people should care about zero knowledge cryptography because, at least in my mind, it's the most significant advance in cryptography since public key cryptography, and I think PK really, enabled the modern internet as we know it. And I think, cryptography really determines what kind of applications and what kind of collaborations can happen between software and people. And zk really opens up this new, very bizarre world where people can, computers can't lie anymore, effectively. And the kind of implications of all of zk, yeah, it's going to be profound. Yeah.
Excellent, and I totally agree, right? We need to continuously advance this industry. zk, I think, is number one on my list of ways to do that. So, again, we're talking about zk adoption here. So how do you think that zk, we'll start with Mikhail, and we'll go down the list again, but how do you think zk is actually going to impact Web3 and the rest of the industry going forward?
Well, it's like, as I said, we're going to be most probably to put like more computation into more restricted environments, which means we'll be able to do stuff we were never able to do before, like regarding, I don't know, like heavy computations without any trust assumptions. So again, it's just increasing the ceiling where the trust assumptions are still required. So that basically, let's how do I put it properly? It's about putting more data, more computation into more restrictive environments. So this is what it's going to be about, and this is what it makes possible, and this is what it is all about. And well, this enables a lot of use cases. Well, again, it's like gaming, whatever.
There you go. Awesome. Leo?
Yeah, I guess the more people care about their knowledge, like the more benefit the Web3 community can have. Yeah, so just think about like how many ZK skins like we can have for each year. Like each year there will be like several like new skins coming out. They have better performance and they will require less resources in the proof generation, and it will cost like maybe less gas in the proof verification. Like so, the more people care about the ZK, and the more people like working on this, like the knowledge that it will like bring like more benefits to the Web3 community in general.
Carson?
Agree with Leo. So like basically, I feel like the zk will unlock a lot of potential for blockchain, especially because like for instance, if you want to enable smart contract to do complex model computation, it's basically impossible, right, on chain. But you can do it off chain. Like Brian said, like zkP can guarantee the integrity of the computation of this off-chain behavior, and then submit the result to blockchain. So in the future, like zkP will unlock a lot more usage that we never even think about it can be possible.
Yeah, basically agree with everything everybody else said, but I think if you look at zk and the kind of projects that were just on the last panel and the ones that are on this panel, you know, these kind of projects are really enabling the creation of like the missing infrastructure layer that blockchain, I think, needs to be able to support applications that are sufficiently rich to, you know, attract more developers and more users.
That's the hope, right? We hopefully this, you know, by next year we've onboarded the next billion users. We keep hearing that sentence over and over again, right? But there are barriers to entry to especially to zk, because it requires a special kind of nuanced knowledge. Leo, what are some of the other barriers to entry as we move forward with zk adoption?
Yeah, so based on my experience, I think the barriers are mainly in two sides. The first one is like zk, like to write the zk circuit, you actually can, yeah, so like if you are quite familiar with the programming languages, it doesn't really help a lot in writing the zk circuits. So that's like what Leo and Risk Zero they are doing. They help us like lower the barrier in the programming part to help us like to write more efficient zk circuits. And the second part is like the proof generation. Since the proof generation takes a lot of time, if you just run it on CPU or on GPU, so that's why like we need some hardware acceleration to accelerate the proof generation. Like so that's what Sysig is doing. And also for HyperOracle, they are exploring like more like zk use cases. Like this will like also lower the barrier, since it will attract like more people to the community. Yeah.
Brian, I see you shaking your head over there. Would you like to add anything?
Yeah, I mean, I think the major like sort of barriers to zk adoption, I think a big part of it is the fact that a lot of the projects out there are, you know, kind of inventing new languages and kind of pushing people towards learning how to program circuits, which is fun and difficult, but it presents challenges for security, auditing, all kinds of things like this. So I think, you know, to really leverage zk to its maximum potential, we need to let people, you know, build programs the way people normally build programs. And I think, you know, got a bunch of projects here doing that, so probably get some agreement there.
Absolutely. Carton, would you like that?
Yeah, it feels like the entry barrier, right? It's like there's two part. There's two kind of problem. The first one is like the performance of zero-knowledge proof. That is like Sysig is solving. Basically, can lower this entry barrier. And another problem you solve by zkVM, like RISC-0, zkWASM, zkLVM, and all kind of this zkVM will allow user to program the circuit without knowing too much knowledge on how to make a circuit, right? So yeah, the one is like performance problem, another is like how to do it problem. Yeah, so that's my understanding for the entry barrier and adoption right now.
Totally agreed. Mikhail, would you like to add anything?
Well, it's like let's say it this way, besides everything that has been said, it's like a large barrier to more widespread usage is the absence of understanding of like use cases. It's like, for example, there are like a lot of use cases outside of this industry, which could have used a little bit less trust to like trust a third party or something like this. But well, let's say this way, they're huge. They require a lot of stuff to be computed. They require a lot of stuff to be done. Like, I don't know, again, games, ML, whatever. A lot of use cases in there. So it's all about, yes, it's all about, first of all, performance, which, in my opinion, it has to be put into market dynamics. But anyway, well, it's just, okay, obviously, that's the first thing. The second thing, it has to be possible to simply bring them to the industry. Not just, reinvent, not to rebuild, not to do anything, just to bring them just fast, time to market, like minimize time to market to zero. That's what it is about. So just to experiment more, just to be able to experiment more with use cases, we're gonna reduce the time to market to zero. So that's basically what it is.
Absolutely. I'm going to ask this of Brian and then open it up to everybody else. But what are some of the priorities that people working with spreading the word of zk should be focusing on? Maybe and what should those priorities be? Maybe over the next year, 2 years, maybe 15 years out, right? So, what are your thoughts on what we should be prioritizing?
Yeah, I think that a lot of companies have been doing a good job, and we prioritize sort of building educational materials and content that's accessible to a very broad variety of users. So I think the space really needs to continue to invest in that kind of material, but also start to talk more about like applied zk and maybe a bit less about like how to build your own zk system, and maybe more about what you can do with zk. Like, I think this is the 1 year answer. I think over the next 2 to 15 years, I do think hardware acceleration is going to become very important, because I think that this technology will end up in some chip in pretty much every single robot that's ever made. So, yeah.
Carton, would you like to add?
Yeah, that's basically what I think too, actually. Yeah, so personally, I think right now for blockchain, we still have a lot of problem waiting for be solved, right, with the zkP. So even for the problem, like indexing problem, automation problem, and zkML problem, like enable smart contract to do complicate behavior problem, like all these problems, I think we can solve with Zero Crew with the increased computational power we have within this 5 years. That's basically what I think.
Leo?
Yeah, so basically the three barriers I just talked about, they will be greatly improved in the next 5 to 10 years. Like the programming language part, the hardware acceleration part, and also the new use cases for the large proof. They will be greatly improved in the next at least maybe 3 to 5 years. Yeah.
Mikhail?
People always try to, when they are being asked, what's going to happen in 5, 10, whatever years, they always try to extrapolate what's going on right now, and something like extrapolate what's going on right now and to see what could it lead to. And guess what? They always fail. It's so I would say we should try to predict this stuff. We just gotta be ready to change rapidly. That's what it is about. So.
No, that's very true, right? So I'm an economist, so I have to study history all the time. We never know exactly what's going to come out in the future, but hopefully we can always try to push the boundaries of what exists now and kind of move the thing forward, which gets me into the ultimate question of this panel. We always hear about privacy. We always hear about zk rollups and privacy and privacy and privacy. What else can we apply zk to besides just the privacy thing? Where else can we go with this? And I'll start with Leo. And we'll work our way there.
Yeah, so recently there are a bunch of zk bridge projects coming out. They want to build a bridge, a cross-chain bridge, showing the consensus on one blockchain can be verified on another blockchain. So that's one project, one bunch of projects that's coming out. And there's another one is the combination of the knowledge and the machine learning. Yeah, it's a huge benefits that can use their knowledge to show that you really use the specified model to do the inference not by just the runs-on-chip model. Like for instance, if you use GPT-3, like the customer wants GPT-3, but you use GPT-2 to run it, and using their knowledge will prevent things like this happening. Yeah.
Carton, what are some other applications besides privacy that we can apply ZK to?
Guys, basically, the core essential what we are working on HyperOracle is like use zero-knowledge proof to ensure the integrity of nodes. That is like run by probably somebody in middle of nowhere, right? And so like this thing will enable a lot of usage. Like first, like basically you can index the blockchain data. We do an output Oracle. You output the blockchain data, and everybody can access it with somebody else. That's like zk indexing. And you can also have zk automation. Basically, like you can do the historical blockchain data verification in current block, and that will enable a lot like fully on-chain gaming and enable some better DeFi clearance mechanism for stablecoin and so on. And like I think the next biggest thing will be the zkML and the zkDID. Like the zkML basically will enable like a lot more complicated on-chain behavior. So right now, if you write a smart contract, all the logic of the contract is on-chain. Like people will easily understand what it is, how it do, and how to attack it, and like it's also super simple. And like, but with the power of zkML, it will be super complicated in the future. And the second one is like the zkDID, like Sysmo, like OutDID, especially OutDID. Like I feel like they are pretty special one. They basically like they scan over your passport and then in your phone and then turn it into a proof, so that like all this DAO and smart contract, the DeFi project can do a KYC on their user and customer. I think like this part will be really helpful on adoption rate and like also like for regulation compliance in the future. And so to Leo mention the zk bridging stuff like Succinct Lab, like Polyhedra, basically they're working really well on this zk bridging information exchanging stuff. It will enable a lot more usage in the future.
Yeah, I think DID and zkML are definitely two things I'm most excited about right now, I think, and have been for a long time. But a really interesting use case that I don't know that most people are aware of is using ZK to sort of solve the software security supply chain, sort of the security of the software supply chain. So for critical applications, you can actually like compile your code in a ZK context and produce a proof that a certain binary came from audited code. And then when that code's used in production, say in semi-autonomous like robots or in defense applications or even just in network infrastructure, you can prove that the computation that's being generated at any point in time that's probably part of some control loop actually comes from verified source code. So there's actually the National Renewable Energies Laboratory actually has been doing some work on using ZK to verify, the control logic on various bits of power generation equipment, because it's very decentralized and distributed in a renewable context, is actually, performing as the grid operators intended to. So I think there's going to be a huge expansion of those use cases.
Yeah, that's pretty interesting. Maybe it feels like, it's like a zkDEP, the DE physical infrastructure thing. Like, it probably is like a new thing I learned today, like the ZK decentralized physical infrastructure.
Mikhail?
Well, it's like, again, we're all playing with trying to combine like privacy and compression properties together in different manners. So it's like, well, gaming, yes, you're right. It's basically about the compression. About the supply chain stuff is, well, yes, it's kind of about the compression of the execution. Yes, that's true as well. Well, it's like, I don't know, just imagine any use case you need to do a lot of computations and then not to trust them. Well, is it like again machine learning stuff? Is it like again video analysis? It's like whatever. It's like it's all about combining these two properties together to achieve some new properties. So yeah.
So I'm what I consider a Bitcoin maxi plus. So I see not, so Bitcoin's all that matters, but I see the utility in all of these different technologies, right? And I believe that the future is going to need privacy, and it's going to need an alternative that you're going to be able to use both, right? So you're going to have to use Bitcoin, and I think you're going to have to use something that has zk within it to have your privacy on one end, because you don't want your barista to know that you just spent money X, Y, and Z other places. So my question, one of my questions is, I want you to spend 1 or 2 sentences convincing a Bitcoin maxi why they should care about zk over just trying to use a different address for every single purchase. Let's start with you, Mikhail, who's smiling, who's like, I would just tell them that they're an idiot, but don't tell them that. How would you convince them?
Well, in case this cult will ever be able to accept anything new in their consideration, well, they will consider that. I don't see that happening.
Leo?
Yeah, so like Bitcoin allow you to do some trading, and with zk, like you can have like all kinds of features you want on Ethereum or other chains. Yeah.
So like, as Bitcoin Maxi, right? Have you
Maxi Plus?
Okay, Maxi Plus.
This
okay.
is very important. It's not like I don't own Monero and a Zcash and everything else.
Basically,
this
like,
is a very important distinction.
Same problem I have when in high school was like, what if the people in like 20 years, how they verify the blockchain data today, right? Like, the only way you can do is basically zk. Like, so I know a project built on Bitcoin right now is called ZeroSync, and then they basically like do the status proof for Bitcoin. So like any people even in, Bitcoin can be mined for 100 years, right? So like people in 80 years from now, they can still verify the data we have today on Bitcoin. That's like the magic, the power of zero knowledge proof.
Like, come on, they will still do that. Like, come on, you don't underestimate the power of the cult.
Yeah, I think that zk's really, as you've noticed, there's a lot of excitement in the Bitcoin community around, JPEGs and attaching them to block space to, increase fees. But really, with Taproot, you can probably incorporate like zk computational capabilities into Bitcoin, and that should help keep the fees high enough to make sure it doesn't, die under in its own deflationary death spiral.
I feel attacked. No, just kidding. We'd like to open up the floor to questions and answers. So if anybody has any questions. Question? Can you give him the mic real quick, Brian? I'm sorry.
Thanks. Question for Brian. I'm a hardware designer. Very much excited about this approach, hiding zk complexity behind RISC architecture. So you are the first coming this way. What roadblocks do you see for us as circuit designers, hardware designers? What should we pay attention to when we try to follow you?
Cool. So if I understand the question correctly, it's what should hardware designers be paying attention to? Well, definitely your logo. Inganyama has the best logo. But no. I think that, at least from our perspective, I think that the bulk of zk use cases are going to be, blockchain is going to be a huge part of it, but I actually think that these kind of future use cases of smaller, like low power, like zk chips is actually going to be a much like higher unit kind of market. That's definitely a bit out there time horizon wise. So I would say that's something to pay attention to, is like how small can you make and how efficient can you make a chip that can run control circuitry on zk? Yeah, smaller hopefully, than a mobile phone.
Would anybody else like to add anything? We're good. Any other questions from the crowd? Don't be shy. It's okay. It's nobody up here, right? Yes.
Okay, great, nice. Thanks, guys. How do you guys see the zk mining market playing out? It seems like there's going to be a lot of hardware that's going to be available to accelerate zk computation. Is it going to be kind of the same like proof of work? How do you guys see this playing out? Cool. Thanks.
It's
Great
like
question. Great question.
It's
Start.
like
I guess we can start with Mikhail first, and we'll work our way down. Good.
it's like now I gotta ask, was it somebody like who sent you to ask this question like specifically about us, or or have you come up with it yourself? Okay, well, it's like the marketplace is. I mean, it exists. It's out there. It's different from what it's different from what it was. It's different from what it was in Bitcoin, because in Bitcoin you cannot trust with the hash you have found to somebody. So you cannot outsource that. So there's no like explicit market. In here, there's actually like a way to hide this data in case not to trust the intermediary. In terms of you can outsource the proof generation, and that's actually exactly what we did. Actually, we introduced such a marketplace, and we allow folks to hide their proofs. We allow folks to outsource the proof generation to somebody, and there's like an actual exchange, okay, like an actual marketplace of proofs. That's what it is. So yes, it exists. It's out there, and it's being used. Folks are building on top of it. That's what it is. I mean, I don't know. Just find me around. I'll show you if you want.
Was the question, just so I understand the question, you're asking about zk and consensus mechanisms, and you're saying with the advent of all the zk hardware, will you end up with like proof of work chains similar to Bitcoin? Oh yeah, I see. Will there be a proof of work economy? Yeah, I think I'll just go with that. Yeah, Mikhail's answer. Basically, there will be marketplaces for proof generation. I think quite a few of them. We're launching our own.
Is one.
Alio has one. They're launching one.
There is one.
So yeah, definitely. And because these things are, you don't need to do, like Bitcoin, you have to do a bunch of wasted work because that provides the macroeconomic security. In zk, you don't need any macroeconomic security. You just need to run a proof and verify that you did it right, and then you can effectively, collect money for that. So I actually see, zk as being the technology that will enable, a decentralized level of infrastructure that approaches AWS or GCP. So in that sense, yeah.
Yeah, I feels like if you want to have the proof marketplace, right? The very first thing you need to do is like make all this proving schema become decentralized. Like right now we have like a schema like Hyperplonk, like Dworgo, and this kind of schema. Like they are pretty, and the zk especially, it's like they are pretty much like focused on distributed instead of decentralization. Because when you have a proof marketplace, you need to trust somebody. Like that person doing the proof for you, you don't know are they executing this proof like honestly. And also like the reason why I mentioned that is like because like without the decentralized proving schema, all we can do is just like in the proof marketplace, everybody need to have like a computer with 500 gigabyte of memory and all this ASIC stuff. It's not that, the market is not that big. Like, but if we can have like people with like 5 gig memory of computer to be a prover, that will enable make this prover marketplace a way bigger.
Yeah, I'm just trying to extract the question from your answer since I didn't get it very clearly. Yeah, so I just talk about our vision for SciSig. Yeah, so SciSig is doing hardware acceleration, and we will build our own ASICs, and with our own ASICs, we will build a proving network. And then like everyone who wants to use fast proof generation, like zkP proof generation, they can just call the APIs of our proving network and then do the work. Yeah, so that's what we will do. Yeah, I guess like hopefully like Leo Foundation, like if they want to use the prover market, like we can also provide some support for that. Yeah.
Thank you. Great. I thought that was great. You have another question, Ed?
I'm curious about programming languages in particular. How should one evaluate How should one evaluate differences between different languages to generate circuits, right? There's like Circom, there's Aztec Noir, there's like Cairo, there's a bunch of these. So like, how should one like be thinking about advantage, disadvantage, and how does that translate into different properties?
It's like, do you want a joint answer? We got the same answer to that.
Yeah, I mean, go for it, and then I'm sure I'll have
You don't need a special
comments.
language. There is no need in special language. Just write in CPP or in Rust. That's it.
Yeah, I would have a more nuanced answer and say that at least the way we think about the world is like, it's just like, if you look at the current world of, programmers and electrical engineers and people who are building hardware, there's always a need for people who know how to build circuits, and I think that will always be the case in zk, but I do think that, over time, there'll probably be fewer and fewer circuits needed. But if you're dead set on writing circuits and deciding how to evaluate them, I think it's important to look for, like Noir is adding support for multiple backends. I would just say try to find a circuit programming environment that doesn't back you into a corner, because I think the last thing you want to do is invest a ton of time building your zk circuits and then have something change and a new system come out and then kind of be stuck in a sort of stuck ecosystem.
Yeah. So zkVM is definitely one of the good solutions for this. Because developer have many different levels, right? Like majority are developer that junior level, and some of them are really senior. And I think for seniors people, they definitely can make their own circuit in the way they want. But for majority of the developer, I think zkVM will be one of really useful thing for developer to do it. Like right now in HyperOracle, we use the zkWasm right now. So basically, the developer, all they need to do is just write a sample script, which is a high-level language, and then convert it to a Wasm bytecode, and then generate the proof for the logic. So with this execution trace, we can basically allow zkP to be accessible for a normal developer instead of super junior one with the math PhD, something like that, right? And that's what I think for this part.
Yeah, I agree with what Cartin said. It highly depends on the developer's experience. If you're quite familiar with assembly, maybe you can try Circon. If you are quite familiar with Rust, you can try RWorks. If you just want to write some learn zk fast, you don't have any experience with the first two languages, maybe you can try some DSL to learn how to program in zk. So that's my opinion on that.
Awesome. I think we got time for one more question. If anybody has one more question, I think we could fit it in. You're getting greedy, but that's okay. You can have another question. No, I'm just kidding. Go ahead, grab it.
Sorry for hogging it. Okay, so does the downstream application change the accessible hardware acceleration that you use? Because I'm thinking of, let's say that you want to, because zk is about privacy, and if you're going to create a zero knowledge proof, you have to use private data. You have to commit private data to that proof. So that doesn't. To me, it seems weird that people will just send that private data to someone else to create that proof for, and then so how does that play into, the types of hardware acceleration available for certain applications?
Okay, so the question was saying how to handle the hardware acceleration for different settings.
Yeah, and I guess specifically for private applications.
Okay, yeah. So for this private application, so actually, we talked to some companies, they have some private concern, which means their data cannot leave their company. So in that sense, maybe we can deploy several of our servers if they are ready in the future, in the near future, to their companies, and they can just do the proof generation within their company, but still using our servers. So our main business model will still be this proving as a service to all other customers, but for this have some high level of privacy concerns, we can just deploy our servers in their company to do the work.
Yeah, I would say certainly which proof system you pick has an impact on what kind of algorithms any particular hardware is going to need to support. So Starks that we use don't rely on MSM, which is notoriously complicated. So I think for private applications, for a lot of proof systems, you'll be able to get sufficient acceleration just off of your GPU, even on your mobile phone. I think it will be there. But I think long term also, the chip in your mobile phone and every chip and every laptop has like 20 accelerators, including stuff for media decoding and cryptography. So I would expect there to be like at some point, everybody will have a zk kind of coprocessor probably attached to their chip, and that's where most of the very private data will go. There's also potential opportunities to use like AWS Nitro or other trusted execution environments as a way to give you the temporary privacy you need to run the zk proof.
Yeah, like definitely. So, yeah, so it's like the way people make this hardware and chips is based on the demand, right? Like back to like 15 years ago, like people want to play video game. That's why I have a graph card and stuff. And then definitely zk chip is most likely to be the next GPU thing for this computation. And also I agree with Brian about like this like hardware thing is really based on what library, what ZKP schema you are using. If we check like all the projects, including us, that partner with like sizes, like they're basically all of them are ultra prompt like Hello 2 library user. So like it's like really depend on what library you use and what hardware you choose.
Just a little bit of addition to what Brian said. Yeah, it all depends on the proof system, but let's say it this way, there will be a coprocessor, so it would be possible to to handle all the necessary proof systems primitives, so that wouldn't be like dependent on which particular application wants to provide you privacy properties or whatever. So it's just having universal chip for many different like proof systems, whatever, in your phone, and you're gonna get it all.
Is there any more questions from the audience? We got nobody else, right? So I just got called on the 10-minute card. So we got 10 more minutes left. So I'm going to ask this question now. Go ahead, Brian.
No, I just say that's a lot of minutes.
That's a lot of minutes.
You're going to have to ad-lib pretty hard there.
So I go to the doctor in the future, right? I don't want to tell the doctor some certain things about me, but they use zk knowledge to know that my blood type, they know certain things about me that maybe I don't want to tell my doctor everything. Maybe I don't want to tell my lawyer everything. How does the future look? Fully adopted, zk technology. How does the future look that way, Brian? We've accelerated. Everything we said on this stage, we've accelerated. There's hardware. It's in your phone. Everywhere you go, you're talking to you're on a dating app. It's all zk now. Everything is zk, right? How does that future look?
That's a good question. I think it really depends on what you're doing. So as a consumer, it should look like you should have a lot more high reliability applications that are less tied into owned ecosystems. So maybe you won't have to log into Facebook with everything, and maybe we won't get so much disinformation and spam, and the kind of quality of the content and social networks that people have available to them will be a lot higher.
Yeah, like we don't need like everything to be zk. Just one thing, like if we resolve the zkNL problem, that you can basically generate proof for any machine learning model efficiently. Even we just solve this problem, the world will change completely. Because a normal program, not machine learning model program, they are basically like a singular cell. Like if we use biology creation to compare it with it, they can only do predefined behavior. But for machine learning model, they can do the behavior is not predefined. It's like a multi-cell thing. It's non-linear behavior. So what I think is crypto, if we solve the zkML problem efficiently, the cryptos will be the cyberspace for all this AI creation. It's up to how you define life, right? According to physicists, normally they will say if there's a form of living that is doing the decrease of the entropy, you can call it life. So basically, this AI can be called life. Essentially, they use computation to decrease the entropy of the system, and then this AI just competing each other in the crypto space. They're running their own model for this DeFi project. How to do the arbitrage is the most efficient, and then I do arbitrage better than you do, and then I am the better AI, and then now everyone is running me, not you, and then tomorrow another guy invent a better AI based on this, and then his AI model replace this one. So the evolution will happen inside the crypto for AI model, AI life. So that's why I think even with just so one thing, it will make the thing become huge deal already.
Yeah, so I think so right now the main applications of zk is still in the crypto space. Yeah, so in the future I could say maybe there would be more applications in the traditional space to use for instance we can use zk to fight disinformation. There is a recent paper by the group of Dan Bonnet to say we can use zk to fight disinformation for some pictures, for some videos, or even for some for pictures and videos. And yeah, so I could say maybe there could be some other more novel applications in the traditional space. Since right now almost all the attentions coming from the crypto space. If we lower the barrier of the ZKP adoption, we may attract more people in the world to work on ZK to explore new applications. Yeah.
Let's say it this way. It's like, as I said, when folks are trying to predict the future, they always fail. So let's just take a, I don't know, unexpected turn and say that we would need not exactly proof system based stuff, but arithmetization-based stuff, I don't know, cryptographic obfuscation for running, for example, proprietary algorithms without disclosing them in trustless environments. Something like, I don't know, jump trading or Jane Street being able to trade on DEXs without disclosing their algorithms. So that's an unexpected take. That's arithmetization-related take. Another arithmetization-related take is about hiding the data in trustless environments. So that's basically about the homomorphic encryption stuff. So that is again arithmetization-related trick, not the proof system-related trick. Arithmetization-related trick. So that might be something. It's like a lower-hanging fruit than trying to push forward for a space which actually ran out of use cases already. So it's let's just yeah.
So part of my, and lower hanging fruit is going to lead me to my next question. So part of my job as a researcher and then as someone who writes reports on cryptocurrency and the blockchain industry and everything else is trying to explain it to my grandmother, trying to explain the newest thing, right? So one of the ways that I try to explain this is zero knowledge proofs. I go, one of the great applications could be voting, okay? So voting, right? And in the last two presidential election cycles in America, I don't care about your politics. I don't care. There was a little bit of controversy on who won each one. Zero knowledge proofs, to me, I think is a perfect example of where you can apply this. Now, how does my grandmother take, how does she say with confidence, okay, I believe that this actually happened? That's my question, because that's what's going to stop adoption for voting. But I believe that that's a perfect example. So how do we bridge that gap?
That, I'm not sure about. I think there are a lot of obvious applications for voting for ZK, and I actually think that we'll see, rather than seeing governments adopt ZK voting anytime soon, we'll probably start to see DAOs are going to adopt this, and governance tools are going to adopt this, and I think you'll start to see, I don't know if you've noticed, but pretty much all survey data nowadays is completely garbage. But once you have zkDid, you might actually, and sort of, proof of humanity, you might actually be able to get survey results and incentivize people to participate in these kinds of things in a way that you can trust the results. And so I think will be kind of a gradient of trust that will kind of evolve because of these technologies. Now, how you get anybody to explain them, or how you explain these to people in a way that makes sense is difficult, but you can definitely make a receipt that you get when you vote that you can later scan with your phone with a QR code and create a proof that your vote was tallied. So if you're worried that your vote wasn't included in the final tally, you can actually prove that it is without risking giving any information away about how you voted. We actually have an example for that in our repository. But.
Yeah, the DID is definitely is important thing. As I said earlier, Sysmo and the LDID, that scan the passport definitely can verify a person on chain. It's yeah, and basically, yeah, zkDid is useful.
Yeah, for the voting scheme, I think like first like we need to use zkDid to prove that the voter is actually like eligible to vote. Then after that, he will generate a signature which will bound on his tally, and then we need to generate a zk proof to say like who vote for what, and we can create a set, and we can say who votes for what. So it's a membership problem. Like we can already solve it with ZKP. And the real problem is like how the government or the other agencies, they are willing to deploy this this system. So that's like something like more in the society issue. It's not a technical issue.
It's like you do understand that that voting trust issues do not originate from the trust issues to the system which recorded it. You know, all the voting issues are actually like produced by the underlying conversations which people are not happy with, not with the process, how the voting was handled. So simply proving like the fact that you voted some way, you know, makes no sense. So you actually got to prove that all the conversations underlying which led to this vote has happened, and without like disclosing them, and that's a much more complicated process to do, and I don't even know how to prove that, like, to be honest. You gotta like digitalize everything that is happening, and only then you'll be able to record it somehow, only then you'll be able to advertise it somehow, and only then you'll be able to prove it. So it's like, it's not about the voting process, like screw zk voting, it makes no sense. You gotta prove on the underlying process.
Yeah, actually I have another thought about it. So like, you know how US government to identify a person, right? It's not based on your passport, driver license. It's actually based on your test record. And like, so I'm thinking if like the zkDid, like besides scanning your passport or driver license, we probably can have like kind of like a zk oracle that summarize abstract entity on the blockchain. For instance, somebody probably have like 10 different EOA, right? And then do the taxation every year. So like this a group set of account, they will basically become a actual entity, abstract entity. Even the government doesn't know who they are, but they still like can collect the tax from them. And then that will be really helpful for crypto space to be compliant in United States.
I have one.
Go ahead.
On one quick thing, and that I think
I can see you moving over there. Go ahead.
Yeah, I think that by having the ability to, you know, anonymously vote in a qualified manner, you might start to see, like, you know, who knows how long it will take America to create, you know, or other societies, a more responsive democracy. But you might be able to see kind of overlay, you know, governments where people basically vote more consistently and thoroughly on issues in a way that, you know, their elected officials can actually trust people's feedback, and then that might actually, you know, kind of have a secondary effect on the efficacy of government, maybe.
Awesome. Love ending on a controversial topic. So thank you guys for listening to the panel from Cointelegraph and from the rest of zkDay. I'd like to thank everybody and enjoy Denver and enjoy the rest of the conference. Thank you very much.
Hello. Thanks everyone for attending zkDay, and this will be our last but not the least ZK panel. ZK EVMs, on-chain superpowers, and security. Let's welcome Drew from Brevin Howard Digital, Ryan from Modulus Labs, John from Veradice, Ye from Scroll, and Neil from Eclipse.
Nice. Thanks for sticking around, everyone. Hopefully we keep this panel spicy. Got some hot takes coming, I think. Just chatting with the guys earlier. The one thing I'll note is we added a panelist. So on the title, there should be something about modularizing blockchains. So laid out. But why don't we start? I know we had some intros from the sponsors, but just quickly, if we can go down the line, who you are, what you're working on, one thing you're going to ship in the next year, and one thing that keeps you up late at night.
All right, sounds good. Hello, everyone. I'm Ryan from Modulus Labs. I'm the CTO and co-founder, and we are working on verifiable AI using zero-knowledge snarks. So it's all the buzzwords that you've heard about, zk, AI, but we were here before ChatGPT. We were here before all of that. And in essence, I guess what we're going to ship in the next year, so we are working towards basically a custom prover that is specialized for basically AI operations. It will be probably terrible at everything else, but it will be very, very good for deep learning and basically machine learning operations. And I think what keeps me up at night is how nascent the field of zkML is. Frankly, when we started like 6 or 7 months ago, it just didn't exist, right? So zk snarks, as you know, have tons and tons of compute overhead. Also, AI is some of the most expensive compute that you can possibly do in like a non-snark sense. Putting the two together just doesn't seem to make sense. And so now we're trying to show everyone like, actually it is becoming possible. And you can do cooler and cooler things, and that's where the R&D is going, and that's hopefully where we're going as well.
Hi, I'm John. So I am the CTO and a co-founder of Veradice, and we are a blockchain security company. And so we perform audits and develop tools in order to automatically detect bugs in various parts of the blockchain ecosystem. I gave a talk about a little bit earlier today about what we do, so I'll just keep that part short. In terms of what we plan to ship in the next year, hopefully a bunch of auditing reports, I guess, is a good answer there. But probably the more interesting one is tools that allow you to automatically detect bugs in software like zk circuits. And so that's something that we talked about in a workshop today, actually, and it's something that we're actively working on. And I guess since I'm from a security company, what keeps me up at night is probably a little bit obvious. It's a lot of the code that's going into production, which, you know, has, let's say, less than desirable security guarantees.
Hello, everyone. My name is Ye. I'm the co-founder at Scroll, and I work on zk research. So a little bit about Scroll. So Scroll is a native zkVM solution to scale Ethereum. And we are targeting at some bytecode level equivalency. So for user and developers, the experience will be exactly the same as what you do on Ethereum, but much faster, much cheaper, and with a high throughput. And regarding to what we want to ship next year, I think our focus will be like stand by this crypto value and ship a really like robust zk EVM with a sound and a complete zk proof. Like, you know, you don't need to trust anyone. You just need to trust math and something like that. And also, we want to ship a bunch of like research proposals about how we're going to decentralize sequencer and how we're going to improve our security, because we know, like, you know, zk EVM won't be bug-free for quite a long time, and there need to be some kind of governance, multi-prover, like two-factor authentication, and some other way to improve the security. And we have already been working on a bunch of things to improve the robustness and security for our zk EVM, including like in-house security auditing, external collaboration with like world-class like auditors, and work with Veradice on some following and formal verification for our zk EVM. And we want to ship something which is really secure and decentralized in the future. Also, I expect a more creative and novel ecosystem on Scroll, like, you know, that really, you know, leverage this zk EVM as the base layer, like to build something really creative, like even besides DeFi and the current scope of decentralized applications. And we are encouraging a bunch of grassroots efforts, like hackathons. You will see us every site at East Global, and we really want to encourage like more developers building on top of us, and like provide more features at the infrastructure layer for the developers. Yes, thank you.
And Yi, what keeps you up late at night? What scares you?
Yeah, that's
one thing.
That's a good question. So, yeah, sometimes, so as I mentioned, like security is definitely the biggest problem. We don't want to get out one day and find like our TVL go to 0 because of some kind of hacks.
That'd be unfortunate.
Yeah, yeah. So we are working really hard on what kind of security problem can happen, and what's a really crucial part, and we want to really double down on the security side, and yeah, that's the biggest concern, and yeah.
Awesome, Neil.
Cool. All right, thanks for having me. All right, so we're building Eclipse. These are louder. Okay, cool. Yeah, we're building Eclipse, customizable rollups as a service, or like we like to call it, build your own rollup, meaning that you can pick a virtual machine, whether that's the EVM, the Solana VM. You can pick a data availability layer, so that's where the blocks of data are stored, or the blocks of transactions. So that could be Celestia, Polygon Avail. We're supporting EigenDA soon, and a handful of others. And then you build in additional customizations for your app. Maybe you're like a game, and you want gaming-specific features. Then you can build those into your app chain. And the idea is that a lot of these layer 1 blockchains shouldn't actually be layer 1s, such as those that exist in Cosmos, but instead they should be roll-ups, and they could borrow the security from their favorite blockchains like Ethereum or somewhere else. So as far as what keeps me up at night, I'm most excited about use cases for app chains, given that I think historically there have not been that many app chains, because it's hard to bootstrap security. You have to bootstrap a validator set. To do upgrades, you have to finagle these validators to coordinate. Whereas when you're on a roll-up, you actually don't need that same level of decentralization for the sequencer. You can get censorship resistance and other things, but you don't need you don't need as many validators as for a layer 1. You don't need the same amount of stake to decentralize it or to provide security for that network, but you get all the benefits. So I'd expect there to be thousands of roll-ups in the coming years, rather than the few, maybe a couple hundred blockchains we have right now.
Nice, I like it. And I guess, I sit at VC, I'm always curious, sitting on the other side of Zoom. I'd be curious, maybe others are too. So why did you guys give up your life to do what you're doing? You obviously had a thesis. So what was that thesis? And I'd be curious if you're more confident in it today than when you started, or less confident. And we'll just go down the line again in just a couple minutes if you can each.
Yeah, absolutely. So for Modulus, I think our original thesis was actually somewhat around hardware, which is ironic because we're not doing hardware, and we're letting the brilliant folks at CSIC and Supranational and Ingonyama do the hardware stuff. But effectively, the same way that basically GPUs brought about the revolution in deep learning, we figured that GPUs producing somehow, we didn't understand snarks very well at this time, but basically that GPUs producing parallel proofs for parallel compute in a parallel compute setting would be much faster somehow than serial provers. And so this is where we started. I think these days, it's much less about basically that for us, precisely because we're partnering with these hardware companies, and more for basically that we need a custom prover for AI operations. So we recently released a survey paper that basically looked at a bunch of different proof systems and proved a ton of different neural nets in these proof systems, and looked at how all of these scaled. And the end result was that we're close, but we're not quite there. So we need to do a little more on basically the R&D before we can unlock some of the really, really useful models like ConvNets, even potentially language models and generative models that have made AI so magical, I think, in the Web 2 sense.
From hardware to AI, nice. We're going to dig into that a little bit more later.
Yeah, we're not hardware people. Let us be very clear.
Go ahead, John.
Yeah, so I guess for me, before this, I was a PhD student, along with a lot of other PhD students in a group that was advised by my PhD advisor. And basically the area of research that we performed was this area called formal methods. And so we started performing research into how do you automatically detect bugs in DeFi applications? And so I guess the original thesis that we had was that you can automate the process of what a lot of these auditing companies are doing. And in doing so, you can provide faster service and also stronger guarantees. And so that's where we started. And I mean, we're still, very much projecting that image, just because there's no way that someone is going to be able to look over all of the code that is coming out. Like, there are so many developers who are, putting out code in this space, and the idea of having all of that code inspected by a small number of individuals who are, qualified to find bugs in these programs is a little naive. And so for that reason, we believe that you need automated techniques, which is, part of what we're building at Veradice, in order to find these, potentially large vulnerabilities that we've seen in the past.
Thesis sounds strong still. That's good. Yeah.
Yeah, so before Scroll, I work already on zk research. 4 years ago, zk hadn't really attract such interest. Mostly it's about Zcash, about privacy, and it's not really about scaling. And what I used to work on is some hardware stuff, use hardware to make zero-knowledge proof faster, using customized hardware, using GPU, because the poor efficiency is the biggest bottleneck in the past for why it's not largely deployed. And when we start Scroll, before that, I work on hardware and also some zero-knowledge proof for algorithms. And then I move more into some application side, how you use kind of this more efficient prover and a new, better algorithm to build something that's in practice, working in real world, in industry. It's not something just research. So I think when we start Scroll, we just want to build something which, Ethereum transaction is so expensive. We want to scale Ethereum, make the transaction cheaper, and using our kind of, the hardware acceleration we have built using GPU, and also we noticed this kind of improvement on crypto side, how you can make zkEVM become 2 orders of magnitude more efficient than before. So that's why zkEVM become possible 2 years ago. That's exactly our starting point. But now when I start zkEVM, already working on Scroll for 2 years, I think my thesis changed a little bit. It's not just applying this technology to this kind of cases, but I understand more about the Ethereum as a whole. Think of when I started, I think of Ethereum as a settlement layer, which is the most decentralized, tech-wise. But when you really went into this Ethereum community, you find that Ethereum is so unique. It's not just the most decentralized, according to the number of validators it has, but also according to the decentralization across the social layer, how creative the Ethereum community can be, and how many people are really having involved in this kind of social consensus and having this kind of open source community-driven ethos and web. And what we are doing is not only just scale Ethereum on tech-wise, but also we want to extend the Ethereum's ethos and web to more people, to the next billion of people. We want to stand by this crypto value by being the most community-driven, the most secure, and the most decentralized zk rollup. So that's always our thesis. And besides, our layer 2, because we are also co-building this zkEVM with the privacy and scaling exploration team, which is basically the zk team at Ethereum Foundation. So we are literally helping Ethereum to achieve its end goal, which is our is the right way we think we should go into, not only scale tech-wise, but also scale on the social layer. And we also believe that our tech should be driven by this vision and value, and we always hold up to our value and be transparent, be more responsive to our community. Yeah, so that's our thesis change from a more tech-wise to community, ecosystem, and all those vision and value, how you can be aligned, not only on the tech-wise, but also on the the spirit, you are really representing, because you are representing you will be the layer 2 will be the user interaction phase of Ethereum, and you need to really stand by this value that Ethereum has. Yeah.
Nice. Sounds like you're confident. I think crypto Twitter may be even more confident than you are yourself. But Neil.
Yeah. So what initially got me into crypto was I was working at Citadel as a quant in the commodities group, specifically doing power, so electricity, and I was modeling demand for Texas, and there's all these Bitcoin rigs that were actually impacting the amount of demand for power during off-peak hours and things like that. And that got me thinking about just the interaction between crypto and traditional finance in general. And I was interested in bringing a wider variety of oracles to on-chain, because a lot of these crypto miners want to maybe hedge their exposure. Maybe they could more natively lock in a certain P&L by hedging in the power price and a certain Bitcoin forward or something like that. So I was interested in that. And that's not really what I ended up building, but I left in March of last year, and the thesis was just that there'd be like continued financialization or like continued decentralization of like traditional finance through things like dark pools, which, I mean, there's this product called Renegade, which just announced a couple of days ago, which I think is really cool. There's like a bunch of zk oracles coming out, bringing new types of data. So that stuff I think is still obviously true. And the types of infrastructure that we're building can ideally support the kinds of like high frequency applications and like high reliability applications that exist in traditional finance. Where right now, I mean, the blockchains that don't like operate as slowly as Ethereum are like not at the level of reliability necessary in order to support like the 3 or 4 nines of reliability that we expect when we're like working at a hedge fund and you have like billions of dollars on the line. So yeah, that's what motivated my entry into the space, and I think it's just getting better every year. So yeah, I'd say it's been the thesis is still good.
It's good to hear. I agree with that one. Maybe we'll do some specific questions here. You know, zk AVMs are super hot right now. Everyone's calling themselves zk AVM. Everyone's got a test net launching. When I was young, I used to play this game where you'd say a word and then I'd have to say the word. So I'd say the color blue, and someone would think like ocean. So when I'm at drinks tonight, I'm gonna go up to people and ask, I'm gonna say the word scroll. I want your view on how they should respond. So like the takeaway today, what do you want the 1 or 2 things that differentiate scroll from all the other zk AVMs? And then what I'm gonna ask you to do is also politely comment on things that others are doing better than you guys. And maybe I'll pick on Polygon. I know Brennan, well, he lives in Austin. He's one of the founders there, or works on Airmess. So maybe just kind of pick on them. You guys are always collaborating, I guess, on Twitter. So I'd love to know kind of your view. If I say the word scroll, a couple differentiating factors, then say something nice about what others are doing, because everyone's kind of contributing here. It is important for Ethereum. So.
Yeah, that's a great question. So firstly, to answer whose testnet come first. So I think different teams are all making different trade-offs. For example, some project they launch their testnet first, but maybe the trade-off is they don't have a proof. And the strategy we choose is at least you want to have some kind of zk proof, which at least prove that you are a roll-up, right? You need to rely on some validity for your transactions, and so that's our thesis. And then there are also some other announcements, for example, other companies choose to launch later, but maybe they directly launch on Gurley. So I think different companies are making different trade-offs. More aggressive you are, maybe the features you have is fewer. And we want to make every of our release to become very secure and very steady. And we are very transparent and honest about what feature we have. So if you look at our Twitter announcement yesterday, we just released our alpha testnet, and we accompanied another HackMD doc talking about what's missing there and what we have implemented so far to be more transparent. So we are currently working our own pace because we know we take a very difficult approach to go into. So to summarize, Scroll's differentiator. So firstly, on the tech side, we are bytecode level equivalency to EVM. So basically, you can reuse your bytecode, not only your Solidity code, but down to the EVM level. So that makes our implementation become more challenging because you need to support a lot of low-level stuff, and you need to be careful about the compatibility. It's much more engineering work to do, and we are working our own pace on that. So that's one important differentiator, and also we are trying to reuse the Go ECM as our sequencer to maximum our security, because the more overlap you have with the ECM node implementation, the more confident you are behaving exactly the same way. So that's one on the tech side, the bytecode equivalency makes our difference. And second is we are really long-term thinking about the zkEVM direction from the security and decentralization. And that really leads to us having a different roadmap. So for security, we are really taking some actions. For example, we have this in-house security team, and we are having external auditor, we are having fuzzling, form verification, and all kind of research leading down to more secure release. And for decentralization, I think we are unique in our approach to first the decentralized approver, anyone can run their approver at home to increase the reliability. If our approver goes down, you can still run your approver. And also the next step to achieve full decentralization is about this kind of decentralized sequencer. So that vision and value about security and decentralization really drive us to our roadmap. And the third thing really differentiating us is about this kind of, another thing I mentioned about this ethos and web, because we believe in this kind of community-driven approach. So this community-driven approach is even more powerful than just open source, because for our zk EVM, we are pretty unique that we are open source and developed by a large community from day one. It's not like you keep closed source development and then like you open source one day. But I think this community-driven approach should be measured by how many external contributors you have and how many eyes are looking into your code base and how many people are reusing your pieces. And we have a bunch of external contributors from like ETH Foundation, from other protocols, and that really makes your community become really stronger. So I think community-driven really makes us become a differentiator in the long term. And also another one last differentiator is that because we are working on the same zkEVM structure with the PSE team from ETH Foundation, so it's very likely like if ETH want to achieve its end game, it will adopt this kind of architecture, and we are literally helping them to scale. So just a TLDR, so we are like bytecode level equivalent, we are community-driven, and we target security and decentralization, like stand by this crypto value, and we are literally helping ETH to scale, not only on layer 2, but also on layer 1.
Nice. I'll be quizzing people tonight, just so look out for me, all right? Why don't we move on to the next question, Ryan? ML, zk, I don't know. You just must be trying to raise a bunch of money or something. No, I'm kidding. But I'd love to know more about like what were the use cases you thought about, like the first ideas you had, like why are you kind of building this? Tell us a bit more, because I think everyone kind of raises an eyebrow here. So talk us a bit more into it.
Yeah, absolutely. So I think the first thing to maybe clarify for everyone is just what is zkML? Because I think even in previous panels, this term has just been thrown around, or like zk inference or zk training. So I'm going to focus on basically explaining zk inference, which is the thing that we are at least currently focused on. So I don't know what y'all's background is in, I guess, AI or zk, but you can effectively think of an AI model as a factory, right? So you're giving it some inputs, and output you're getting, I don't know, like whatever the factory is supposed to process. And so really, when you're constructing a factory, there's kind of two main phases. There's the tuning phase, when you're setting up all the machines, and you're saying, great, this machine should actually be heating this to like this temperature, or like this machine should be moving its robotic arm around like this. And then there's what we call the inference phase, which is kind of the deployment phase, or when you're actually putting the factory in production, when all the machines are perfectly precise, and all you're doing is just running through raw ingredients through it, and getting out whatever outputs you're supposed to be getting. So this sort of inference phase is what we care about. What zk AI allows you to do is it allows you to say that for a given factory, so for a given neural network architecture, for some given set of basically model parameters, and some input, which is generally public or otherwise signed, this is precisely the output that you're getting from it. In other words, you have trustless machine learning models. No one can possibly mess with this model or its outputs in any way because the zero-knowledge proof doesn't allow for that. Okay, so that's the tech. I think on the application side, so frankly, as I was saying earlier, like literally 5 months ago, this field didn't exist. People didn't think you could do this. And so a big part of, I guess, like company building and building this ecosystem, this nascent community called zkML, is trying to find problems that other people have. So basically, we're not trying to build a protocol, at least not yet. Nobody wants to buy a protocol, right? Everybody wants their problem solved. And so what this looks like is going to individual companies and saying, hey, here's a problem that we think you might have. Here's our tech. Does this make sense? And if that makes sense, they become our early design partners. Insofar as I think concrete use cases, so I think in the far future, we'd like to see language models on-chain. We'd like to see basically an on-chain version of Compass. We'd like to see an on-chain, for example, healthcare provider, where every single decision can be attested directly to that model. That would be amazing. You would never have to basically not trust any like service which is making a big decision in your life ever again. I think in the more near term, it looks more like using the AI techniques which kind of work at a more moderate scale. So one of the first, I think, use cases that we're really excited about is this project that we're doing with an NFT company in which we're doing a zk GAN, or a generative adversarial network. And basically the idea there is that rather than having your model run off-chain, generate basically image inputs, and then put those on-chain as NFTs, the model itself is the NFT. So you have this autonomously operating NFT artist, which is just running on-chain and constantly producing verifiable pieces of art, basically for all to, I guess, consume in some sense. So this is one cool application. Another cool application that we're very excited about is this project that we've been building actually called Leela versus the World. Basically, it is a game in which, if y'all have ever played, like Twitch plays Pokemon or anything like that, it's just everyone in the world gets to play this singular chess game against a singular chess engine entity, which happens to be, in this case, what we call a reinforcement learning policy network. It doesn't matter too much. It's basically just a neural network that takes in the board state and outputs what the move should be. And so the reason that it's important for this bot to be trustless, of course, is because we could just call Magnus Carlsen. We could be like, hey, Carlsen, what's the mate in 3? And you'll be like, oh, it's this. And we'll say, great. Then we'll just put that onto the board, and you would never know the difference. However, in this case, because the AI is verified, you always know that the moves which are being played by the AI agent are coming from the model. And so it is the, I think, marriage of basically where AI is really, really useful or efficient, such as in a chess engine or such as in a generative model, as well as why we need the trustlessness, such as within this game, or such as where your protocol is literally an AI on-chain artist, where we think, I guess, cool use cases really lie, right? Because that's just, I guess, the intersection of what these two pieces of tech are really, really good at.
Awesome. I like it. And John, I wanted to ask, in Vitalik's talk at Rollup Day, DEF CON, he highlighted there's 34,000 lines of code in the PSC prover. I want, A, your guess on how many lines of code there are across a couple of these zk VMs, but B, how are you going to audit all this stuff? I know you talked on your automation tools, so maybe dig a bit into that, but be super curious on that side.
Yeah, so that's a good question. I mean, in terms of how many lines of code there are in the zk VMs, I mean, we already obviously have
maybe he knows better.
Yeah, yeah. So how many lines of code do you have in your zk circuits right now?
It's basically like numerous lines of code. I haven't really counted that, but yeah, that's a lot.
Okay. Yeah, so if we imagine that all of the zk VMs have about the same amount, so let's say 35,000 lines of code, obviously the answer is somewhere around hundreds of thousands of lines of code just for zk VMs. And then if you start considering something like zk VMs, which are building on top of the EVM, then you're probably getting up to the high 100,000s to somewhere maybe close to 1 million lines of code. So obviously that's pretty daunting. And so, I mean, in terms of how do you audit all of that, the answer is you don't. You trust tools to audit that. And so the reason why you do that is because one thing that we see is it's hard for people to reason about these zk circuits because you have to reason about the computation that's being performed and then the actual constraints to make sure the constraints are actually properly specifying that computation. And so it requires a lot of reasoning by a lot of people who are more skilled than myself, but luckily work for us. And it just takes a lot of effort. And so instead, the way that you should instead audit all of that code is with automated tooling, which is what we're building. So we showed some automated methods in which you can detect bugs by looking for discrepancies between the computation and the constraints. And so what I mean by that is when you build a zk circuit, there's some computation that's going to be performed, the witness generation, and then you have a set of constraints over here that's going to verify that that computation was actually performed. And so we have a static analyzer that is able to detect possible discrepancies between those two things. We also have a fuzzer that can automatically create attack witnesses for circuits that happen to be under constrained. And then finally, we have a formal verifier that, or I guess not finally. The third thing is we have a formal verifier that can formally verify whether or not a circuit is constrained or not. And it will output it will prove whether or not that circuit is constrained. And more importantly, if it's not, it will output a counterexample similar to the fuzzer. And then finally, we also have been working on a number of techniques to make it easier for people, because right now this part isn't necessarily automated. So in a semi-automated way, to write proofs in order to ensure that these circuits are correct with respect to the reasoning that the developer has in their mind. And so in terms of like, how do you apply that to, okay, so let's assume that we have all of these tools. Now, how do you apply all of that to this, let's say, hundreds of thousands of lines of code? Well, all of these tools have different strengths and weaknesses. So some of them scale better and some of them, don't scale quite as well. So for example, performing verification with something like a semi-automated verification where someone has to sit down and write at least part of the proof is not going to scale very well either. And so instead, similar to other types of software, perhaps the better way to do it is for the critical logic to formally verify that logic is correct using something that provides you with very strong guarantees, like a formal verifier, or hopefully, eventually, soon, an automated verifier. And then for all of those other cases where they're not quite as security critical, use tools that are capable of finding bugs very well, like fuzzers and static analyzers, which is our other tools that we're developing, in order to identify these bugs and put them in the hands of developers so that they are the ones who are now able to find these bugs themselves and fix them. That way, there's a fast iteration loop.
That's great. I thought you were going to tell me Vitalik should get started reading code, but I guess you got a better solution. Neil, let's kind of finish this section off with you. You guys are building modularized rollups. You guys built a rollup solution on Solana, which sounds crazy to me, but I'd love to just learn more about like why you guys kind of gave the modularizations you did and how you kind of came about that and some of the key differentiations you've found from talking with people across these different networks. I'm bagging on Solana a bit, but there are trade-offs between Ethereum and Solana and things like that. So be curious. And if developers out there thinking about it, like what are the things they should be contemplating?
Yeah, so just to clarify, so these aren't rollups on Solana. They're rollups that take the Solana virtual machine, but they throw away the consensus. They could be deployed to Ethereum, for example. So that's the first thing. But yeah, as far as like why do we use the Solana virtual machine? So we support like other bytecodes too, right? We support executing EVM or SVM, but I mean the secret is that even when we're executing EVM bytecode, it's still using the Solana VM under the hood, because we basically have a smart contract that's kind of like Geth. It's just like a EVM bytecode interpreter. Because the Solana virtual machine is parallelized, it ends up being not that inefficient, and the throughput still reaches like hundreds, if not like low single-digit thousands TPS. Of course, that brings challenges of its own because we are deploying these initially as optimistic rollups, and there's no Merkle tree for the Solana VM. So that means that you have to construct that retroactively or in some way, or like concurrently or something. And the reason why you need the Merkle tree is, like, let's say someone calls for an optimistic fault proof. They're like, I think that was executed incorrectly. You need to be able to say, these were the inputs, commit to those inputs, and you need to be able to re-execute the transaction or instruction and demonstrate that the result is not what like the sequencer claimed. So there's some challenges with it, but the advantage is that if you do get like a full, and also for like the zk rollup, we don't have to do that. Instead, we use RISC-0. And we were approached by like other proving systems too, but we treat it as just like a separate module. And right now we're like fairly tightly coupled with RISC-0, but you can decouple it and we would construct a circuit that's just designed to execute Solana bytecode. And then you can like plug in whatever proving system you want in the future. So the use cases we're really interested in are things like games, like things that require a ton of throughput. We're interested in physical infrastructure networks. So we have this product called React deploying to us. It's like a decentralized battery market. In California, for example, there's a ton of daylight in the daytime. So like you have solar panels, they produce a ton of power. Then in the evening, the sun goes down and the power price goes really high. So you need batteries to take that daytime power and use it in the evening. So that's what they're trying to solve. They democratize and like incentivize people to like plug batteries in and use that. So and they use a token to bootstrap that. So that's one class of applications. Games I mentioned, we have games like Worlds, a lot of shooter games, and games that are not like turn-based. Historically, turn-based games are most popular on chain, or maybe games just put a couple NFTs on chain. that's probably a better use case for something like Scroll or something else. But if you're really using all the throughput that Solana can offer, that the Solana VM can offer, then it makes more sense being on something like an Eclipse chain. And then another use case is, I mean, we announced our Polygon SVM chain. So this is like ecosystems such as Polygon who want to have kind of like a SVM side chain or a roll-up deployed to their ecosystem. We can do that for them too. So there's a handful of other layer ones that are deploying Eclipse chains. We'll be announcing those in the coming months.
Awesome. We'll do one more. We got one more set of questions here. I'll go down the line, but and then we'll take questions from the audience. But what is one area you think is under-researched around zk? Maybe an area you're building in, maybe an area outside, or just kind of one area. If there's someone out here that's looking to go to school or looking to build a project or looking to join the team they can write a white paper on, I don't know. But maybe we'll start with John, then we'll come back, and we'll go to Yi, and then we'll go to Neil. So I'm going to mix it up a tad.
All right. Yeah, so I don't know if I would say under-researched, because I do know a couple of people working on this, but I would say something that's really, at least in the security space for these zk circuits, something that's really needed that people need to perform research on is improving SMT solvers so that they can reason about these circuits. And so let me explain what that means really quick. So in security, there's a particular tool called an SMT solver, which basically just solves mathematical formulas and tells you, yes, this formula is unsatisfiable, or no, it's not. And so in that case, we've seen in a lot of different domains, including in DeFi, a lot of people end up using tools like Z3 in order to prove that a particular DeFi application is correct with respect to some specification. And so there are blog posts about how people have used Z3 in order to do so. But once you move to something of the complexity of a zk circuit, all of a sudden Z3 doesn't scale. The reason is these SMT solvers have a hard time reasoning about nonlinear arithmetic. And for those of you familiar with zk circuits, there's a lot of nonlinear arithmetic that's involved in zk circuits. And so one thing that's really needed is to improve SMT solvers, in particular with respect to finite field computation, which is what's done in this domain, in order to allow them to precisely reason about the semantics of a zk circuit. And so that will help at least advance the security tooling a lot, and will enable a lot of other tools like an automated verifier for zk circuits. In terms of other areas that would be interesting to pursue in terms of research, because right now the SMT solver is not going to scale correctly, another area of research which is interesting and what we're pursuing is how do you end up providing guarantees without relying heavily on an SMT solver. So basically, how do you have interactions between complementary types of analyses in order to allow you to still provide feedback to the user? And so in one of the tools that we talked about earlier, they're called Picus. Essentially the way that we do that is we mix static analysis and an SMT solver in order to verify whether or not the circuit is under constraint. And so in that case, more applications similar to this that maybe use an SMT solver in some limited way, but ultimately perform the reasoning using another method. Like, I mean, in my opinion, something like abstract interpretation or something along those lines. And so it would be interesting to see more lines of research there.
Nice. Maybe we just do one more on the panel. Let's take external questions. Does anyone have any burning research areas? Neil, Yi, Ryan.
Yeah, I can quickly mention some, because we are building zk EVM, I think it's maybe the same apply to zk machine learning. Like we all need some performance prover to make that really, really practical. And there are multiple efforts improving on that front. There are hardware acceleration and better proof system, better recursive. But sometimes that fall apart. Hardware people look at your algorithm and build better hardware for this algorithm. and the software is keep improving the theoretical complexity to get some linear prover or whatever. But I think it's like eventually your system should be a system problem. It's like software and hardware co-design problem to reduce how we design this algorithm to be more hardware friendly, not only on the theoretical level, but on in practical. Assume that even this is very slow, but with hardware, because it can be really parallelized, it can be really fast. So that's some goal we are looking into, how you can coordinate this hardware effort and software effort to really get some performance prover. And so that's the area we are looking into. There are multiple different directions. I think more people should pay attention to this. And also this witness generation problem besides the core computing, which will be a long tail problem for zk acceleration. Because even if you can make your computation, your 90% of your computation become 100 times faster, then it will bottleneck by those left 10%. I think people need to really pay attention to the smaller piece. So that's how you build a really performant zk prover.
Yeah, I think on a similar vein, basically going from theory to practice. So for us, as we were benchmarking a ton of proof systems, it was unclear to us basically whether the verification of this proof could be done on chain. And so even though for a lot of these papers, it's yes, technically O of log n or O of log squared n or whatever is good enough for succinctness, that's not actually good enough for the chain, at least at the size of circuits that we care about. So much more, I think, research into basically how much gas each of these verification operations cost and how much just compute and memory does it cost on the verifier side would be extremely helpful.
Neil, quick comments?
Yeah, I think on that same vein, I don't know if this is a research question or just a matter of seeing how it plays out. And I have my own thoughts on this, but how will value accrue across the stack? For a given penny that's charged to the end user, how much is given to the application versus the prover, verifier, the settlement layer, whatever provides DA, so whatever's storing the blocks of transactions. And part of that might come down to what's most easily replaceable and what's most fungible. For example, something I don't know, DA, you could make an argument that it's more of a commodity than something like a proving system, which is highly bespoke for the specific application that you're running. So, and even hardware, for example. That's why I'm interested to chat with you guys about how you're thinking about your hardware partnerships.
Nice. I think we have time for one question if there are any.
Hey guys, my question is specifically for Ryan. You said you started with the hardware business, right? And you kind of stopped doing that and went in the software business. What are the key learnings for that? And if anyone who wants to start a hardware business in zk Ping system, any piece of advice for them?
I think I'm uniquely unqualified to speak on this point, actually. I don't think we ever started as a hardware business. I think we just looked at GPUs and said, wow, cool, what if we applied those to ZKPs? I don't know, Ye probably has better thoughts on this.
Yeah, so previously we have actually experienced working on customized hardware like IPG and ASIC to make prover faster. And also we have in-house team building GPU prover. And we also published some papers, if you check out, it's on AskPlus, and we have a ASIC paper about how you make this faster through ASIC on ETHDenver. You can check out our publication. But one important conclusion we get is, as I mentioned previously, is software and hardware co-design. It's not only hardware can only compute, make your certain component faster, but if you are talking about the end-to-end computation, because even if, I mentioned, 90% of the computation is accelerated for 100 times, it's still your bottleneck will be the left 10%, which means your end-to-end will be really limited by this smaller piece. Maybe you can decompose large computation into smaller one, and then you keep doing recursion. But that's still software and hardware co-design. That's just all the hardware companies have some kind of North Star for what they are prioritizing for, and they collaborate with some company to know their needs, and then optimize for that target, and then think about how to generate this, how to have some standard library. So another effort we're actually improving on is we want to have some kind of community-owned proving stack so that everyone is reusing the same prover, so that this can become some standard for hardware, and then everyone is reusing the same proving stack. Because another separation, different teams are using different proof system. Even if you have ASIC, it can't be reused. If we are encouraging this kind of community standard, it can really help to this adoption.
Yeah, I think on that point, like community standards would be extremely helpful. I mean, just in our conversations with hardware partners, sometimes it's like, well, we don't even want our prover system necessarily to be on a hardware stack because our own customers can handle like worse latencies in some sense, as long as it costs less to generate a proof, right? Like these ASICs are extremely expensive to basically take the R&D to design and actually manufacture up front. So sometimes it's more of a unit economics thing and less of a like pure performance thing. Yeah.
Nice. Do we have time for one more? I think so. One more? Maybe we're done. If you want a drink, I understand.
For John, and I guess also the whole panel, but I've heard formal verification being thrown out there as a way to prove that certain computations will take place before actually running them. I'm just wondering what that means for your business and also for Modulus in terms of running neural networks, and if we can formally verify certain outputs given inputs. Maybe I'm not understanding it, but would like to hear your thoughts there.
Okay, so let me make sure I got this right. So basically, you want to know a little bit more about how someone would actually go about, performing formal verification on these circuits. Yeah. So basically, the way formal verification works in this case is once it comes to formal verification in these zk circuits, because you now have two components, formal verification becomes more complicated. And so for that reason, essentially what you do is formal verification still requires a specification. So the specification expresses what exactly it is the circuit is supposed to do. And so in some ways, it's almost exactly the same as what you get when you're looking at the computation, because in a lot of cases, the computation and the constraints are supposed to be mirrors of each other. But essentially what you have, you can still have like functional correctness issues, and so for that reason, it's still useful to have a specification that you're formally verifying against. And so in that case, basically what you're doing is you're stating the specification, and then essentially in this, in a zk circuit, you now have essentially two verification problems. So first of all, you need to verify that the computation that you're performing actually adheres to your specification. And second, you have to formally verify that the constraints that you have defined actually are equivalent to that specification, because the specification is and all of that is essentially very much intertwined. And so when it comes to constructing a formal proof, essentially what you're doing is you have this third entity, which is your spec, and you're now proving correctness with respect to that specification. And so if you prove that both your computation and your constraints are equivalent to the specification, then transitively they must be equivalent to each other. And so that's typically how we perform formal verification in our case. And so when we've done this with clients in the past, essentially what we do is we discuss with them like what at a high level their circuit was intended to do. And so like it is supposed to compute X, and we express that mathematically. And then using that mathematical version of that mathematical specification, we prove correctness with respect to that.
Yeah, I guess application to machine learning, I'm not too sure if there are formal verification X machine learning type things. But certainly for machine learning, security is a big issue. And insofar as like adversarial attacks are concerned, and or basically having your model meet some specification, which is nowhere near as well mathematically defined, I would say, as basically a set of like formal constraints, but rather just saying that over this like representative data set, I get some F1 score, or I get some metric that I care about. This is something that snarks are able to basically help you do. But certainly, I think the formal verification for us would come more in the like traditional sense, where it's saying that like the set of constraints that we're using as the circuit for the machine learning model are actually both, I guess, necessary and sufficient to encode exactly the computation that that model is supposed to do.
I mean, maybe we can use your machine learning model to generate the proof. So we'll see.
Now we're thinking. Collaboration, that's good. All right, that's all we got, I think. Are we done for the day? Anyone else talking? And Kenley, I think, will come up and close this out. Is that the thing? So thank you all for listening and staying late here.
All right. Thank you very much. Thank you very much. So I think Drew made a statement earlier asking if we're all ready to start drinking. I think it's about that time. So for now, we are transitioning from zkDay into zk Night. So during zk Night, it's going to be a 3-hour-long event where we can really start mixing and mingling, getting to know each other. We're going to bring up a DJ. We're going to clear the area a little bit so everyone can start networking. We've got games on the side. We still have a workshop going on the second floor as well. And so why don't you give that a visit? By the time the workshop's done and you're back down here, we're all ready to mingle. There will be an open bar. So yeah, thank you guys for coming out to zkDay. Thank you to all of our sponsors and hosts. This has been amazing. It couldn't have been done without all of you. Thank you very much. Thanks, Rayhan. Thank you.